Hello and welcome to this course, Ultimate Linux Guide with Interview Preparation. So, the first question for you, is Linux a good career path? Well, Linux professionals are well positioned in the job market, with 44% of hiring managers saying there is a high possibility for them to hire a candidate with Linux certification. Now, this is the most important question for us. The jobs that you can expect after you become a Linux expert. First, the DevOps engineer, which is very important and crucial job and with a high salary expectation. Java developer as well, software engineer, systems administrator, systems engineer, senior software engineer, Python developer, network engineer. Now, in this course actually, we will handle a lot of stuff and a lot of materials. So, we will learn what is Linux. We will learn Linux from the beginning, history and evolution of Linux. What is the difference between Linux versus UNIX? UNIX architecture, we will have a solid understanding of this UNIX or Linux architecture. We will learn Linux from the scratch. We will start by Linux directory structure. We will have a basic Linux commands. We will be working with the directories, listing files and understanding the ls output, links and the shortcut in Linux, file and directory permissions, finding files and directories, viewing files using Nano and Vim editor. We will be working with the copy command and move commands as well. We will have a solid understanding of the input, output and redirection in Linux. Now, all of these will be in two types of lectures. A theory lecture first, then we will go immediately to the hands-on, the practical, step-by-step style. Also, we will learn shell scripts for the beginners. Finally, the interview preparation. Now, in this course, I will prepare you to go to the interview with a lot of confidence. So, it will be a Q&A, question and answer style. So, I will ask you the question, I will give you some time, and you will try your best to answer it, and I will show you the ideal answer for it. So you will make sure that you have the needed skills and the needed confidence when you enter to the interview. So what are you waiting for? Enroll now and don't miss this chance. Actually, you will get a 30 days money back guarantee. Also, with job guarantee if you follow me step by step in this course. I'm pretty sure you are excited, so I will see you there. Now let's start with Linux from the beginning, history and evolution. So in this lecture, we will learn the history of Unix, why Linux was created, what is the Minix, why Linux is so popular, and points to be noted. Now let's start with the history of Unix. So actually, it started in 1964 in New Jersey when some people of Bell Labs tried to create a multi-user operating system or OS. So they worked on it till 1969. After facing a lot of failures, they withdrew the project. Then a group of 5 people, including Dennis Ritchie and Ken Thompson, successfully created an operating system called UNIX, the Uniplex Information and Computing Service, better known as UNIX. They published this OS as open source, free to use and edit the code base. And in 1975, a version of Unix was released labeled Unix version 6. It became very popular. Some companies tried to make a profit from it. So they made their own commercial version of flavor of Unix, like IBM iX, Sun Solaris, Mac OS, UX, and so on. Now, the question is why Linux was created. So Linus Torvalds, the creator of Linux kernel, in simple words, Linus Torvalds created Linux because he didn't have money to buy Unix. He was a student at the University of Helsinki. In early 1991, he decided to do a project on Unix, but free versions of Unix were too old, and the other commercials are too costly, like $5,000. So he thought of creating his own OS. Now, one question may arise, that is Linux an exact copy of Unix? Is that so? No, actually it is not. Let us clear this for you. For idea purpose, Linus did research on Unix, but more than Unix, he did research on Minix OS. And no, Linux is not an exact copy of Unix. So what is Minix? Now, as you can see from this graphical user interface, Minix was created by Andrew S. Tannenbaum on 1987. Minix is a Unix-like operating system based on microkernel architecture. Now, the term here Unix-like, which means that it runs the same programs, or it is capable of running the same programs or same architecture of software, the same as Unix. So that's why it is called Unix-like. The main reason behind creating Minix is to teach his students and the book he was writing, operating system designs and implementation. And another fact here, actually, Minix is a text-oriented operating system with a kernel of fewer than 6,000 lines of code. Now, the question is why Linux is so popular. Linux is so much popular that most IT companies ask their candidates that do they have knowledge or experience of Linux-based OS. Some points are mentioned below of the reason why it is so popular. Features. First, it is an open source, lightweight, it is secure, it is multi-user, multitask, it is simplified update for all the installed software, multiple distributions like Red Hat, Debian, CentOS, Ubuntu, Kali Linux, etc., etc. Now, points to be noted. Actually, Linux is a kernel and not an operating system. And GNU is a collection of free software. So if you ever heard of this term GNU, okay, it is a collection of a free software that these two projects collapse give us the Linux. Or actually, it is called GNU Linux operating system, which means the kernel and the collection of the free softwares together. Linux is not a Unix clone. It was written from the scratch. A Linux distribution is the Linux kernel and collection of software that together created an OS. Okay, Linux distributions like Kali Linux, Ubuntu, CentOS, Fedora, etc., etc. Some companies and open source communities adopt GNU Linux codebase, did some modifications, and create their own version or distributions. For example, we have the Red Hat, RHEL, we have Fedora, Debian, Ubuntu, CentOS, Kali Linux, and so on. Thanks for watching. Alright, now what is Linux, what is Unix, and the difference between them? Now, Linux is an open source multitasking multi-user operating system. It is initially developed by Linus Torvalds in 1991, and the Linux OS is widely used in desktops, mobiles, mainframes, etc. Now, for the Unix, it is a multitasking multi-user operating system, but it is not free, and it is used not as an open source, okay? So it was developed in 1969 by Ken Thompson team at AT&T Bell Labs, and it is widely used on servers, workstation, etc. Now here are some of the most important differences between Linux and Unix, okay? So the first thing for the development. So Linux is an open source and it is developed by Linux community of developers. But Unix was developed at AT&T Bell Labs and it is not open source. For Linux, it is free to use, as you can see the cost. But Unix is licensed OS. Now for Linux, as the supported file system, we have the extension or ext 2, 3, 4, JFS, XFS, a lot of things, FAT, FAT32, and TFS, a lot of things actually. Now for the Unix, we have the FS, GP, FS, HFS, a lot of things actually. You can see XFS, ZFS, and so on. Now for the GUI or the graphical user interface for Linux uses KDE and GNOME. Other GUI supported as are LXDE, XFCE, Unity, Mate, and so on. Okay. Well, actually there are more to be honest, but these are the ones that I bought. Now for the Unix, Unix was initially a command-based OS. So most of the Unix distribution now have GNOME. Okay. Now for the usage for Linux, it is used in wide varieties from desktop, servers, smartphones to mainframes. But for Unix, it is mostly used on servers, workstation, or PCs. Alright? Now, for the default shell in Linux, they use Bash or the Born Again shell, and it is the default shell for Linux. Now, for the Unix, the Born shell is the default shell for the Unix. Okay? Now, for the target processor Linux was initially developed for Intel's x86 hardware processor. Now it supports more than 20 processor families. For the Unix, as you can see, Unix supports the PA, RISC, and Itanium family. Okay, well, actually, maybe now it supports more than these. Anyway, so for examples on Linux and Unix, so Linux, Ubuntu, Debian, GNU, Arch, Linux, Red Hat, CentOS, and so on. For the Unix, SunOS, Solaris, SCO, Unix, AIX, HP, UltraX, and so on. Okay. All right. Now, thanks for watching. I will see you in the next lecture where we will see and discuss the Unix architecture. I will see you there. Now for the Unix architecture. Well, actually, the Linux as well. All right. So as you can see, this diagram is the basic block of the Unix system architecture. So you can see that the first thing we have the upper layer, which is the application programs. So we have the mail, the FTP, the utilities, the DBMS, and so on. All right. So this is the application layer. Then we have the shell layer. Okay. And the shell layer here, it has the bash, the Z shell, the S shell, C shell, the more, the commands, environment, okay, CPP, and so on. Now we have the inner kernel layer and we have the hardware. Okay, so as you can see, the shell communicate between the applications and the kernel. Okay, all right. Now let's have a detailed, actually, a detailed information. So here are the main concept that unify all the version of Unix. So the first thing, it is the kernel. So the kernel, as you can see, the one here, is the heart of the operating system. It interacts with the hardware and the most of the tasks like memory management, task scheduling, and file management. Okay, so here the kernel is the one that's responsible to control the hardware. All right, but how we control it? By using the shell. All right, so the shell here is the utility that processes your request. When you type in a command at your terminal, the shell interprets the command and calls the program that you want. So the shell use standard syntax for all the commands. The C shell, for example, Bourne shell, Corn shell, are the most famous shells which are available with most of the Unix variant. Okay, so here are the shell. It has a lot of shells like the C shell, Corn shell, Bash, whatever. Okay, so you put your command, interpret it, and it will handle it, or it will communicate direct with the kernel, and then the kernel communicate with the hardware. So no one can communicate through the hardware immediately, only the kernel, and the shell communicate through kernel. All right, and of course, if you have a root permission or full permission, admin permission, then you can do things only the user admin can do it, or the root user can do it. All right. Now for the commands and utilities, as you can see, there are various commands and utilities which can be used in your day-to-day, like the copy, the cp, move, cat, grep. Okay, so some of the examples, they are actually, as they mention here, 250 standard commands plus then numerous others provided, like, or through the third-party softwares. So for example, the ones for the GPUs like NVIDIA SMI or whatever, actually these are a third party. So by default, if you type NVIDIA-SMI, for example, to check your NVIDIA GPU, it will show you command not found, right? Okay, now this command actually is considered a third party, and so on. Okay, now finally we have the files and directories. Like all the Unix is organized into files, the Unix or the Linux organized into files, and all files are then organized into directories. And these directories are further organized a tree-like structure called the file system. Now, actually, don't worry about the commands, don't worry about the files, the management, the processes management. All of the commands at these will be handled in a separate lectures and in detail, okay, with a practical way, okay? So don't worry at all. But again, here are the diagram for the architecture of Unix or Linux. We have the application, then we have the shell, we have the kernel, we have the hardware. The application here, which is the mail, the FTP, the telnet, actually the terminal emulator considered to be application, okay? Because the terminal is something different than the shell, actually. The terminal emulator act as the shell to be something showed off to us, okay? And the shell is the concept, or is the term that responsible to communicate with kernel, okay? So it is as a logical, not as a thing, okay? So finally, we have the kernel and the hardware. The hardware like the CPU, the RAM, the disk, whatever. All right? Okay. Now, thanks for watching. I will see you in the next lecture. Now let's start with Linux directory structure. Now, as you can see from this image, actually, this is the Linux directory structure. So this is like a tree. And from here, you can see that we are starting from the slash. Here slash, which means the root directory, which is where everything starts. Now, we can start from the bin. Now you can see slash bin, which means the bin directory inside the root directory. And by the way, the bin here is for the user binaries. We have the sbin for the system binaries. We have the etc configuration files. Don't worry, we will talk about each one of them in details. As a low-level details, everything you need, it will be handled in this lecture. No worries. We have the div for device files. We have the proc for the process, or the proc for the process information. We have the var for the variables files. We have the temporary files, slash user for user programs, home for the home directories. This is for the users, the home directory of the users. The bootloader files, the lib, system libraries, opt, the optional add-on apps, mnt for the mount directory, media for removable devices like USB, CD, etc., etc. Back then floppy, if you are aware of this, it was an old storage media, and srv for the service data. Okay, now let's start one by one. First, let's start with the root or the slash. Now every single file and directory starts from the root directory. Only root user has write privilege under this directory. And please note that the root is the root user home directory, which is not the same as slash. So we have actually two places. Please don't get confused. So we have the slash alone, which means the root directory of the all of the system files, okay, as we mentioned before. And we have the slash root. If we return back here, actually I didn't put it here because it is not important that much necessarily, but actually I should have put it here, which is the slash root. Okay, so it should be one of these, slash root, which is the home directory of the root user. Okay, don't worry, we will handle that in details. Okay, so the slash root is not the same as the slash. Slash root is the home directory of the root user. Okay, and slash is the root directory of all of the files and data of the system. Okay, cool. Now let's start with the bin or the user binaries. It contains the binary executables. Common Linux commands you need to use in a single user modes are located under this directory. Commands used by all the users of the system are located here as well. So for example, the ps command, ls, bing, grep, cp for the copy, and etc., etc. Okay, the sbin, the system binaries. Just like the bin, the sbin also contains binary executables, but the Linux commands located under this directory are used typically by the system administrator for system maintenance purpose. And for example, iptables, reboot, fdisk, ifconfig, swapon, and so on. Now let's start with the etc, the configuration files. This contains configuration files required by all the programs. This also contains startup and shutdown shell scripts used to start, stop individual programs. For example, etc resolve.conf, etc logrotate.conf, and we have that. If you install nginx, you will find it here. If you install Apache, you will find it here, MySQL, PostgreSQL, etc., etc. Okay? This is the configuration files for specific programs. Now let's start with the div devices or device files. This contains device files. These include terminal device, USB, or any device attached to the system. For example, div tty, which is the teletyper, type 1. Okay, don't worry, we will talk about this later on in this course. The div USB moon 0. These are examples. Now the proc or the process information. This contains information about system process. This is a pseudo file system contains information about running process. For example, /proc PID. the process identifier directory contains information about the process with that particular PID. So for example, you are running specific service or specific process with PID. Every information or pseudo information will be found here, okay? And under the proc slash the PID, for example, 900. If you go to the 900, you will find that all the information about this specific process. This is a virtual file system with the text information about system resources. So for example, the proc uptime. This is one of the processes. Now let's start with the var or variable files. var stands for variable files. The content of the files that are expected to grow can be found under this directory. So this includes system log files. So for example, /var log, packages and database files /var lib, emails /var email, printq /var spool, log files, for example, /var log, temp files needed across reboots /var temp, and so on. Now let's start with the temp or temporary files. Directory that contains temporary files created by system and users. The files under this directory are deleted when system is rebooted, because this is a temporary after all. The /user or user programs, it contains binary, libraries, documentation, and source code for second level programs. So for example, /user bin contains binary files for user program. If you cannot find a user binary under /bin, look under the /user bin, for example. For example, let's see at awk, the command for awk, cc, ls, scp, all of that will be, most likely, will be located under this directory. So the /user sbin also contains binary files for system administrators. So, for example, if you cannot find a system binary under sbin, look under the user sbin. For example, again, atd, cron, sshd, the user add command, user del command. So to continue, user lib contains libraries as well for the user bin and user sbin. And the user local contains users programs that you install from the source. So for example, when you install Apache from source, it goes under the /user local Apache 2. Okay, so again, the /user here is for the user programs. Okay, and it is under it you can find user lib, user bin, user local, user sbin, and so on. The home directory /home. This is the home directory of all users to store their personal files. So for example, we have user called John. It will be /home/John. Again, Nikita /home Nikita, and so on. Okay, the personal files of these users will be here under the home. The same as we mentioned before, the root, it will not be /home root. No, it will be /root directly. Okay, because this is the root user. After all, it should be separated between the regular users, right? /boot or bootloader files. It contains bootloader related files, kernel, init.rd, VM Linux, grub files are located under the /boot. For example, init.image-2.6, etc., generic. This is one of the files that needed for the bootloader. And another file is VM Linux, etc., generic. Okay, this is the version. It doesn't matter for now. This is just an example. So these are files very important for the bootloader. So it will be located under the /boot. The lib or the system libraries. This contains files that supports the binary located under the /bin and sbin. Libraries files are either ld star or lib star, okay, .so star, etc. For example, ld 2. etc. .so, lib courses.so 5.7, etc. These are just another examples. The opt or optional add-on applications. So opt stands for optional, contains add-on applications for individuals vendors. Add-on applications should be installed under either opt or opt subdirectory. Okay, so anything inside the opt. The MNT or mount directory. Temporary mount directory where a system administrator can mount file system. Okay, So you want to mount a specific file system, network file system, okay? You will most likely mount it here by default, unless you want it another place. The slash media, the removable media devices. Temporary, this is a temporary mount directory for removable devices. So for example, slash media CD-ROM, this is for the CD-ROM. Media floppy for the floppy drives. If you recall these actually is a very old one. They are not exist anymore. Actually, the CD-ROM is not exist anymore, but some are still using it. Media CD recorder for CD writer, and so on. The SRV or service data. SRV stands for service. It contains server specific services related data. So for example, slash SRV CFS contains CFS related data. Okay, thanks for watching. Now let's start with the basic Linux command. So in this lecture, we will learn what is the basic Linux commands, what are the environment variables, and what is the $path. This is a variable and it is very important environment variable. We will learn what it is. Now let's start with the basic Linux command. Now, the first command, this is very basic and very important command, and you should know it by default, the ls command, or the list directory content. So in Windows, we call these as folders. So the directories or folders, these are the same, okay? But in Linux, we name it directory. In Windows, we name it folders. CD, this is to change the current directories. PWD displays the present working directory. This is the present working directories. It stands for this. Cat, this is for the concatenation. Concats and display files. This is used most likely for text files. Don't worry, we will talk about these and we will have a hands-on lecture later on. Echo, display arguments to the screen. And man, this is to display the manual. And this can be used with specific commands to show with a manual for them. Now, what are the environment variables? Now, if you ever heard about these, or if you didn't ever heard, no worries, I got you. So environment variables are a set of dynamic named values stored within the system that are used by applications launched in shells. There are system-wide and user-defined variables. So for example, the system-wide variable is star or $path, okay? This is really important and very important environment variable for the Linux system. Now we will talk about it in the next few slides. What is the $path? The path variable here is an environment variable that contains an ordered list of paths that Linux will search for executable when running a command. So using these paths means that we do not have to specify an absolute path when we are running a specific command. Now don't worry, we will talk about this in details in the next lecture. All of these commands will be handled in the next lecture, the hands-on lecture, okay? But for now, keep in your mind that these are the basic commands, okay, that we will be using in the next lecture. And the path, $path, which is the environment variable, system-wide environment variable, this to tell where are the path of the binary or the commands, okay, that we will be using. So instead of using absolute path, we will use, in that case, a relative path, or where it is located. No worries. Don't worry, we will talk about all of these in details in the next lecture. I will see you there. Alright, now it is time to start with the basic commands. The first command we will use, which is the ls command. ls, which is listing the files or listing objects, directories, whatever. So if I type it like here, you can see that I have the workspace directory, remote.jar, whatever, remoting directory, and so on. By the way, directory means folder in Windows. So if you are coming from Windows, directory for Linux, and Windows, for Windows, it is called folder. Okay, anyway. Now, to see where I am currently, yeah, you can see that I have this tilde, and this tilde means that the current home directory for the current user, which is the home Ubuntu user. So you can see that from the prompt here, we have the Ubuntu, which is the user, at the name of the IP, the name of the current computer, or let's say current server, the name of the workstation, whatever. Okay, so if I type the pwd, which is the print working directory, you can see that I am inside the home Ubuntu. All right, so far so good. Now, if I want to change the current directory, if I type ls, you can use the cd, which is change directory. cd to workspace, for example. Let's go to workspace. And here inside it, you can see that we have this specific things, whatever, okay, which is another directory. All right. Now, actually, for the ls, it has a lot more options like ls-l, a, t, h, actually a lot of things, but we will talk about these in a separate lecture. Now, what if I want to see, or let's go to another place, okay, or here like this. Okay, now what if I want to see the content of this remoting.jar, but maybe it is a binary, I think I can't see. I will use the cat or concatenation tool, which is the cat remoting.jar. Let's see if that will work. Yeah, you can see it starts showing the content of this file, but yeah, as you can see, because this is a binary file or executable file, so we cannot see its file as a string. We will see as arbitrary values. And again, we have the echo command, and this echo command is used to print the argument or a specific argument. So for example, we have environment variable called path, for example. So if I type echo with $sign and path as a capital, you can see that we are printing the environment variable path, which is something good. And by the way, the path environment variable is used to store the location where the binaries are located. Now, as you can see, the current screen is very messy. So if I want to clean it, I will use the clear command. Okay, so clear the screen. All right. Now, what if I have this specific command, for example, the ls, and I want to see all the options, the documentation, the manual for it? I will use the man page. Okay, so if I type man, you can see what manual page do you want. So if I type man, which is the manual for the man, and you can see that, yeah, it will start showing what is the name, which is an interface to the online in reference manual. And you can see that a description, options, overview, a lot of things actually. All right. So what if I type man with the command I want, which is the ls, for example? You can see that ls, it is used to list directory contents. And you can see that we have the -a option, which is all, -a almost all, -b, c, f, g, z, x. As you can see, actually it has a lot of things, and the status, the author, bugs, whatever. Okay, so actually everything as a manual will be there. All right, which is the man by using the man command. Now, where to find the ls command? So I know the ls command is used to listing directory, but where it is located. So how to know a specific command where it is located? I will use a command called which, and this which actually it will tell us where is the binaries are located. Okay, so if I type man the which to see, as you can see, it is used to locate a command. So here, which return a path names of the files or links which could be executed in the current environment, whatever. Okay, blah blah blah. Now let's try use it. So which ls. Oh, you can see that the ls command is located at the /bin/ls. So if I go there, if I type ls to the bin ls, you can see that, yeah, it is here, as you can see. By the way, don't worry about the listing or the ls command. We will have a separate or a complete lecture for the ls, ls-l, a, t, and c. What are those? So if I type here ls-l, you can see that there are a lot of things, which is the long list, by the way, long list format. You can see that a lot of things here. What are these? What is D? What is RWX? What is this Ubuntu? What is this numbers? What are those numbers? All of that will be discussed in that lecture, so don't worry for now. But for now, we took a brief about how Linux works and what are the basics commands that I will use them every day, every moment. We will continue learning more and more in the next lecture. Thanks for watching. Working with directories in Linux. Now in this lecture, we will learn the Linux special directories, absolute path versus relative path, directories commands. Now let's start with Linux special directories. Now in Linux, we have a special directories and indicates for specific functionality. So for example, we have the dot directory, which is the current directory. So when you type ls-la or ls-a, you will find that we have this directory everywhere. Okay, don't worry, we will handle that in the hands-on lecture, in the next lecture. But for now, keep that on your mind. So the dot means the current directory. The double dot or dot dot, which is the parent directory of the current directory. Okay? We have the slash, which is the root directory. So if you type cd space slash, okay, this will go to the root directory where all of the file systems will be there, or the folders. We have the tilde, or the current user home directory. So for example, we have user called John. If you type cd space this tilde, it will go to the home directory of the current user. Don't worry, we will handle that in details in the hands-on lecture, the next lecture, no worries. Now, let's have a comparison or a differentiation between absolute path and relative path. So actually, the absolute path is defined as specifying the location of a file or directory from the root directory. So for example, you will go to the specific place. You will, for example, you want to go to this folder inside John home directory. You will go cd slash home slash John slash then this specific folder, for example, example1 folder. Okay. Now, please, this is just a theory lecture. In the next lecture, we will have that in details, no worries. Now, the relative path, on the other hand, is defined as the path related to the present direct working directory. So, for example, if I want to go to the previous directory and I want to go to a specific folder, I will go cd dot dot slash folder 2 slash folder 1, etc., etc., all of that, no worries. Now, let's have just a brief about the directories commands. Okay, now we want to use the cd. This is very important command, the change directory to cd dot dot. This is to change the directory to the parent directory. Cd slash, this is to change the directory to the previous directory. Works like back. Okay, how it is in Windows, we use the back button or whatever. This is like the back. And pwd, this is the print working directory command to show the full absolute path. We have the make directory. This is to make a new directory. And we have the make dash p. Okay, as you can see, we have this argument or this parameter dash p to make a new directory with dash p, which means parent. As if the parent does not exist, create as well. Okay, so for example, I want to create two folders inside each other. I will create make dir dash p folder 1 slash folder 2. So it will create folder 1 and inside it will be folder 2 created. Don't worry, we will have that as hands-on in the next lecture. Also, we have rmdir. This is to remove a directory, and actually this directory should be empty. Remove dir dash p to remove a directory with dash p parent, as delete with parent as well, as our previous example, which is make dir dash p folder 1 folder 2. It will be rmdir dash p folder 1 folder 2. Again, we will have that in details in the hands-on lecture, no worries. rm-rf, and this is to remove a directory using the rm command with the recursive, as you can see, dash r, which means recursive, and f as a force option. So we have two options for this rm, dash r, which is recursively remove everything. So for example, folder 1, our previous example, folder 1 slash folder 2, we will remove folder 1 and folder 2 because recursively, because it is r, and f because it is forced. So don't give a warning, remove force. Now, we have reached to the end of this lecture. In the next lecture, we will learn all of these, what we have learned here. In theory, we will apply it, and we will have a hands-on in the next lecture. I will see you there. Now it's time to talk about the directories. So now the first thing I want to mention, we have two path types actually, the absolute path and relative path. So what are the absolute path and relative path? Now, the absolute path actually, so if I type the pwd, you can see that I'm starting from the slash, which means the root directory or the root directory of all the system. All right, not the root home directory, by the way, which is slash root slash root. This is the home directory for the root. Okay, so slash home Ubuntu. This is the absolute path for this directory or this current directory. All right, now if I want to go to workspace, if I type ls, you can see that I am inside the Ubuntu home, but you can see that I have workspace and we have the remoting directory. So if I want to go to workspace, I can use just cd workspace, right? like this, all right? Now actually this is the relative path, but the absolute path is like this. So you can see that when I typed bout or pwd, I took that. So I'm starting from the scratch or from the root, home, Ubuntu, then workspace. Okay. All right. By the way, I need to provide a cd here, actually, the cd command. Yeah. So you can see that. Go to home, Ubuntu, workspace. All right. If I type here, yeah, it works as well. So this is the difference between the absolute and relative. Relative, which means it is relative to my current path, which means if I want to go, so if I return here, so if I want to go to workspace, so if I want to go to the workspace directory, it needs to be in the current path, okay, which is the current path here by using the ls command. Then I can go cd and put its name. But if it is not, I need to provide the absolute path, which is starting from the root, what we saw, which is the home, Ubuntu, and then workspace. So far, so good. Now, we have two things I want to say. Now, we have the dot, and we have the dot dot, okay? All right. Now, the dot, which means the current directory. Dot dot or double dots, which means the parent directory. All right. Now, what are you talking about? We don't understand anything, actually. Okay. Now, if I type this command ls-a, which means all, everything, print everything here, you can see that now we have other directory, other things. Now you can see that we have dot bash history, dot bash, dot something, and by the way, anything started with dot like this, dot viminfo, dot ssh, dot profile, these are a hidden files or directories. So you can see that this is a directory, but because it is started with dot, which means that this is a hidden directory. Now this is profile, dot profile, which means a hidden regular file, text file, all right, and so on, all right. Now you can see that, yeah, these are normal directories and file. Some of them are hidden by starting with dot, and some of them are not, like these, like the remoting.jar, whatever. But we have these two, which is the dot, and we have the dot dot, or double dots, I mean. The dot, which means the current directory, which is the home Ubuntu, all right, which is the Ubuntu directory, the home directory of the Ubuntu user. The dot dot, which is the parent directory of the current directory, which means what? If I am assuming that I am on the Ubuntu, which is the parent, yeah, you are right, which is the home, yeah. So why? So how to use these actually? Yeah, good question. So let's clear the screen first. Let's put ls command. Now we have the workspace, right? We want to go to it. We will use the workspace like this. So far, so good. ls. Now we have this directory, whatever. It's okay. Now, what if I want to return back? Should I provide the absolute path over and over, which is cd home Ubuntu over and over each time I go there? No, actually, this doesn't make sense. Now, actually, there are two ways. The first thing, we have an alias or something called, but just typing the cd command like this and press enter, this will return to the home directory of the current user, which is the Ubuntu, which is home Ubuntu. Okay, so like this, you can see that we return back. But imagine if I am inside the workspace, and inside a workspace I have in dir 1, and inside directory, the first directory, and the second directory, third directory. So I am very deep into the workspace directory. I don't need to return to the home directory of Ubuntu, then go again, then go. No, this doesn't make sense, right? How to do that? So let's create the screen again. ls cd to the workspace. Now, what if I want to return back? You will use the parent directory, which is the dot dot. Okay, so cd dot dot means I will return to the parent directory of the current working directory. Okay, so the current directory is workspace. The parent directory of it, which is what? Yeah, which is the Ubuntu home directory. So if I return like this, so you can see that we have returned back. Now actually, so let's go again. Actually, by the way, you can put slashes, by the way. So cd dot dot. Now you can put here, put it like this, I mean. And inside it, you can put workspace, then return, then workspace. So you can see that now, actually this is somehow weird, but you can see that I am returning back, then I go again to workspace. I return back, then I go again to workspace, all right? By the way, the dot dot here or double dot is inside every directory in the whole Unix system. Okay, so every directory has two special directories, which is the dot and double dot. The dot for the current directory, and dot dot, which is the parent directory. Okay, now you may ask me, but we know what is the double dots. What is the dot? Don't worry, we will talk about these when time comes. Don't worry. Okay, so let's execute this command. We will return back. Currently, we are in the workspace directory. We will return back, then we will go again. We will return back, then we will go again. So let's see. Yeah, actually, this doesn't make sense, I know, but actually, it's good to understand how the parent directory or the directories work inside Linux. So you can see that, yeah, everything is working as expected. All right, so we return back, then we go again, return back, go again. Okay, now another thing. Now, how to create a directory? Now, this is what we are talking about. We want to create a directory and we want to remove a directory. Okay, the first thing is use the make dir command. So this command will create a directory. So let's name it dir1. Let's put ls. Yeah, dir1 is here now. Let's go inside it. dir1. Cool. So far, so good. So if I type ls-la or -a, which means everything, you can see that we still have these special directories, which is the dot and the dot dot or double dots, which is the current, which is the dir1, or the parent. And the parent for dir1, what it is? Yeah, you guessed right, which is the workspace. Yeah. So far, so good. Now, I want to create another directory inside dir1. Make dir or make directory dir2. Okay, now let's go inside it, which is dir2. All right, so far so good. Now I want to give you another shortcut, which is the cd dash. Now cd dash actually works as the back. So if you are opening your browser, for example, this is just arbitrary example, okay, or a simple example, and you go inside this specific website and you need to return back. So you press or you click on the back button, right? So actually this works like this, cd dash. So you can see that. So I am currently in the cd. So let's return back on the dir1. You can see it like this. I have the dir2. I go to dir2. If I type cd dash, it will return me back to the dir1, which is this one, okay? It will give me the absolute path, which is this one. Now you may ask me, but I got confused. Please, what is the difference between the dash and the dot dot? All right, please don't get confused. I will explain that in details. So first thing, I want to go to workspace. All right, okay. Now inside it we have the dir1. Please ignore this thing. Okay, we have the dir1. Okay. Now cd dir1, and I don't need to press enter then cd dir2. No, I will put dir2. Okay, I will press enter now. So you can see that I am inside the dir2. And the parent for it, which is dir1, and the parent for dir1, which is the workspace, and so on. Okay, so if I type cd dot dot, where it will go? Yeah, it will go to dir1. But if I type cd slash, which means return to the previous directory, which is where? Which is the workspace, not the parent for the dir2. So let's see. Yeah, which is the workspace. So actually, this means return back to the previous current directory, to the previous working directory. You got me now? So this is the difference between the dash and dot dot. So far, so good. You saw how we created the dir1 and dir2. Okay, now it's time to remove the dir2, okay, or dir1. So let's go inside the dir1 first, and let's learn how to remove a directory. So here you can see that the first thing, I will use two commands. Either one will work fine, but from my opinion it is better to use the second command. I will talk about it. So we have the rm dir. This is to remove a directory, but actually this command require you that the directory is empty. So you can see that inside the ls dir2. By the way, if I type this, it will list all the content of this directory, which is dir2, which is empty, by the way, you can see. And if I type rm dir like this and remove dir2, yeah, you can see that it has been removed. No problem, okay? So let's make a directory another. Let's make it again. Okay, yeah, it is here. Yeah, it is here, as you can see. Now, actually, the second command, which is the thing I recommend you, or it is better for you, which is using the rm command. Okay, so rm, it is removed. So this actually remove regular files, remove linked list, remove directories, whatever it is. Remove directories recursively, by the way. So you can see that if I removed the dir1, it will remove everything inside it, no matter what. Empty, not empty, whatever. Okay, but I will use the -r command and f, which is the force. So rm to remove, r recursively, f force. So remove the dir2. And you can see it has been removed. All right, so far so good. Okay, now actually I want to talk about another thing here. So let's return back, or before I return back, actually let's make a directory which is dir2. So to show you that if I remove it, if I remove the dir1, you can see that, oh no, directory is not empty. But if I type rm-rf dir1, you can see it has been removed successfully. So far so good. All right, so far so good. Now I want to create a directory dir1 and dir2. So if I type make dir1, and if I put the slash dir2, and by the way, the slash here, which is the forward slash, in Windows it is the opposite, which is the backslash. In Windows it is the backslash, in Linux it is the forward slash, which is this symbol. Okay, if I type this, you can see that no such file or directory, which is what? Which is the dir1. As you can see, dir1 is not existed for you to create it. So how can you create dir2 while dir1 is not existed? So we will use option using the make dir, which is the -p option. Now -p option used to create a directory or make directory, and if the parent is not existed, which is in our case the dir1, create it please. Okay, so let's type here. Yeah, so far so good. dir1 has been created. So let's go inside it. Yeah, first let's clear the screen, sorry. Yeah, and inside dir1, which is we have dir2. Yeah, everything is working 100%. All right, now let's cd here. Actually, this is to return to the parent, which is the dir1, but I don't need to go to the parent, which is dir1. I need to go to the workspace. How should I do this? Well, actually, maybe you don't know about it yet, but actually we can use the dot again. All right, you got me? You can use dot not just once. Actually, let's have details. cd dot returns to the parent directory of dir2, which is dir1. Okay, so if I type here, which means return to the parent directory of dir2, because of dir1, sorry, because currently after we execute this command or this directory, after we go to this directory, to the parent directory of dir2, which is dir1, we will go to the parent directory of dir1, which is the workspace. So this will return me back to the workspace. So if I go here, yeah, you can see that I return to the workspace. So actually it is simple. If you imagine it, it is very simple. Return to the parent directory of the dir2, which is dir1, then return to the parent directory of the dir1, which is workspace. So actually no big deal. Please don't get confused. It is very simple. Okay, and by the way, you will get used to it. Don't worry at all. Believe me on that. I'm telling you. Now, ls command, you can see that we have the dir1 as well. Okay, now we saw that by using the rm dir1, we couldn't remove it because it is not empty, because it has the dir2 as well. Okay, so how to delete directories recursively? So imagine I want to remove the dir1 and everything inside it. I will use this time the -b option. Okay, so if I type it like this, you can see, yeah, the directory is not empty. But if I type dir2, so actually this will remove everything. So if I type ls, yeah, you can see that dir1 has been deleted, as well as dir2, which is as expected. But you can see that using rmdir, actually it is safe. Yeah, it is safe somehow, because imagine you have this very important directory and you want to delete it, for example, after you archive it, for example, but you remember that you didn't archive it yet. So using the rm-rf is very dangerous in this case. But by the way, nobody do that. Actually, everything is automated currently. So and if it is something important, you don't remove it. So actually using the rm-rf is better from my personal opinion than using the rm-dir. Yeah, I know rm-dir is more safe, because if you want to check if this directory is empty or not, you can just put the rm-dir. If it is not empty, it will not be removed. But rm-rf, it will remove everything no matter what, by using the f, by the way, f option, which is force. But actually it depends on what you prefer. From my opinion, or my personal opinion, I prefer using rm-rf, because actually you have a lot of work to do. So it's not time to check this is empty or not. I know it is empty by doing the ls command like this. So ls, the name of the dir, which is dir1. By the way, I already removed it. So ls dir1, it will show everything inside dir1. As simple as that. Then rm-rf. Yeah, I know we will have a shortcut. Instead of doing that, we can do the rm-dir, whatever. Okay, so it's up to you what you prefer. But I'm telling you, I'm teaching you every command that used here for you as a DevOps or as a developer. All right, thanks for watching. Okay, now listing files and understanding the ls output. Now the ls command, okay, it has a lot of arguments and very useful arguments and parameters. So ls by itself, it will listing the files, the default one. Now ls-l, this is to give the long list format, okay? Don't worry, we will use it in the next lecture. ls-t, this is to sort with the last modified time. So the files we seeing, or the file directory we are seeing, it will sort the output with the last modified time. ls-h, this is to show as a human readable. So for example, instead of seeing 1000, we will see 1k, which means 1 kilo, okay? And so on. ls-a, this is to list all files, a as all, okay? Include hidden file included. Hidden file like dot, the current directory, or dot or .ssh or .aws or whatever, etc., etc. This will be hidden file, and it will be listing it. We have a combination of all of these, ls-laht. So this means that list with the long list format, a for all files, h for human readable, as well as sort the output as with the last modified time. So as you can see, it will show us a long list format with everything needed. So you can see that we can use a combination, but use the dash once. Don't use it many times. Actually, some terminals or some shells actually accept to put the -l space -a space -h space -t. It doesn't matter. But some, these are forbidden, will not work. But the right way actually, and the most general way to do a combination of arguments is to do this like this. -laht, okay? And one single dash. Don't put many dashes. Okay, in the next lecture, we will talk about these in details in the hands-on lecture. I will see you there. All right, now it's time to talk about the ls command, which is very important command, the listing command, with more details and more options. Okay, so actually you can just type man ls, and here you can see all the options, all the things, all the values you want. Well, it's not like about these, but I want to mention the most important ones. Okay, so let's return here actually, and let's put the ls. You can see that we have these. Now the ls-a option, this to print every directories or every file, including the hidden one. So ls-a, and you can see that, yeah, we have the .sudo as admin, .vim info, .profile. By the way, anything is started with dot as either as a regular file or a directory or a linked list or whatever files, it will be considered hidden. Okay, so using the ls command by itself, it will not print anything, but ls-a, it will be, or they will be printed. Okay, so far so good. Now we have the ls-t, or let's talk about the ls-l. Okay, sorry, let's clear the screen first. So yeah, ls-l, which is this one. So actually this will print the current files, but as you can see, we didn't include the a, which means only the visible, not the hidden. Okay, only the visible file and directories will be listed. And you can see that we have the L here, which means the long list format. Okay, so you can see that including what is the type, what is the permission, links, user, group, last modified date, and so on. Okay. Now, what if I want to combine the ls-l with all, which means I need all the files, but I need them, the hidden files included as well. I will put ls-la or -al. It doesn't matter. The order doesn't matter. Okay, so ls-la, which means it will print everything and as a list or a long list format. Okay, so you can see that, yeah, we have everything here, and here are. Don't worry about the permission, about the user group, what is d, what is slash. Everything will be discussed, but later on the next lectures, not in this lecture currently. Don't worry at all. And we will have everything in details there, and you will get to understand everything. So no worries. Please don't be afraid. Do not panic. You will understand everything, and you will start looking at these. Oh, this is very simple. I know everything. Okay. Okay. Now let's talk about something else, which is the ls-l, but this time with h. So you can see that the numbers here. Now don't worry about the numbers. We will talk what are those numbers. But for now, you can see that the numbers here is very big. So you can see this number. What is this number? It doesn't make sense. Okay. But by typing the h, which means human readable, so the number here will be like this. Okay. So you can see that. Let's clear the screen first. Sorry about this. So ls-l-a-h. Okay. So long list, all files, and as a human readable. So you can see that now it will be 4K, 1 megabyte, 4K, 107, whatever. Actually, these are bytes. Okay. So if I type it without h this time, you can see that here is 4K, but here is 496. Okay. Now this is easy actually, because we know that this is 4K, but for number like this. Okay. By the way, it is easy as well, but actually, when you have a lot of job, a lot of tasks to do, your daily task, so you will not have this luxury. Oh, it's very simple. No, actually, your mind will be very busy. Okay, so it's better to use the h to print it as a human readable, which you can see that here it is 1.5 megabyte. Okay, and here is 1,500,000, whatever. Okay, all right. So far so good. So h, I combine it with the la, so it will give me that we have it as a long or as a human readable. Okay. Okay. One last thing I want to mention, which is the LA. Let's put the ls-la. Okay, and ls-lat, but this time. Okay. Now t, it will be sort the times or sort the files depend on the last modified date. Okay. So you can see that here. These are the modified dates. So you can see that here it is from 29 December, here is 29 December, May. As you can see, they are not ordered. Okay, but here by using the t, they are ordered currently. So you can see that the up to date is here, which is 29 December, and here actually this is July, then we have the May, then we have the April as well. Okay, so you can see that we have the files ordered, not as a listing here, actually as an alphabetic. You can see that we're starting from the B or dot first, then for the dots we B, C, D, E, F, G, whatever. Then we have the without the dot, I mean D, A, B, C, D, R, W, whatever. Okay, here is by default is the alphabetic order, but if using the T, we will sort them depends on the last modified date. Okay, all right. So far so good. Now again, don't worry about the permission, what are those number, what is root, what is Ubuntu, what is those. Don't worry, we will talk about these in details in the next lectures. Okay, so keep with me for now, understand or practice this ls, because the ls is very important command for you as a Linux administrator, DevOps, developer, whatever. Okay, all right, thanks for watching. I will see you in the next lecture. Now, links and shortcuts in Linux. So in this lecture, we will learn the links command in Linux, the hard links versus the symbolic link or the soft links, and what is the inode. Now, the commands, the links command, actually, it is the ln. This is to create a hard link. Okay. So ln-s, this is to create a soft link, okay, or symbolic link. This is the same as shortcuts in Windows. Now, what is the difference between hard links and symbolic links? Hard links and symbolic links are two different methods to refer to a file in a hard drive. Okay, so hard link is essentially a synced carbon copy of a file that refers directly to the inode of a file. But the symbolic link, on the other hand, refers directly to the file which refers to the inode, the same as shortcut in Windows. Now, inode, what is this inode? Don't worry, I got you, we will know what is inode. So inode, or the index node, is a data structure in a UNIX style file system that describes a file system object such as a file or directory. Okay, so each inode stores the attributes and disk block locations of the object's data. File system object attributes may include metadata, times of the last change, access modification, as well as owner and permission data. So let's have this. This is actually a picture. So you can see that we have a file descriptors like 0, 1, 2, 3, 4. Don't worry, we will talk about the file descriptors in details later on in this course. We have, as you can see, this is 0, for example, it is read, and this is for the etc password, for example, file. So this file, inode table, you can see that the file table is read and the file descriptor is 0. So the inode table, it will indicate that this file has this specific information. And now actually this is just a simple example. Okay, don't worry, we will talk about this in detail later on. Thanks for watching. Now it's time to talk about the linked list or the listing or the shortcuts inside Linux. Okay, now actually for that we are using the ln command, which is the link command. So man ln to see, so you can see that make links between files. Okay, so here are the synopsis. You can see that the first form, the second, the third, fourth. You can see that we have a lot of options, a lot of arguments, the author, whatever. All right. Okay. Now, as simple as that, what is the most important? For example, let's make a directory. So let's name it ln dir. Okay, whatever. Okay. So now I want this ln dir to be linked. So let's make dir2. It's okay. And actually to make this directory without go to the directory, we already learned that. So dir1, and then we create dir2. And if it is dir1, if not existed, we can put the -p or -p option. So to make directory if the parent is not existed, but the parent existed, by the way. And ls-la or ls-l, sometimes some of the Linux distribution, it have this alias, which is the ll, which means the ls-l. Okay, by the way, it is alias. Now what is alias? Don't worry, we will talk about alias later on. All right, now let's start using the ln option or ln command. So ln, the source, the destination. Okay, but by the way, it's better to use absolute path in my case. So you can see that if I type baud or pwd, you can see that I have the home Ubuntu, then ln home Ubuntu, ln dir, and this means that I want this directory to be linked to another directory. Okay, so I want this lin dir, and I will go home Ubuntu, and I will put lin dir2. Okay, all right. So you can see that now hard link are not allowed for directories because we are linking between directories. We cannot do a hard link, so we will use in this option the soft link or the symmetric links. In other case, actually in Windows, they are called shortcuts. Okay, and they are very simple, by the way. But just by putting the -s option, which means symmetric or soft link. Okay, so by this, yeah, everything is as expected. You can see that lin dir2 is now referring, that the one we created here, as you can see, which is the destination, is referring or linking or linked to lin dir, which is this one. Okay, so far so good. So actually if I type ls-l now, you can see that here ln dir2 is now, as you can see there are arrow, is now listed or is now linked to the home Ubuntu in dir or lin dir. Okay, so if I go to lin dir2, it will go me to the lindir2. Actually, if I create a directory here, let's name it dir, for example, whatever, okay, and I return back, let's clear the screen first, then I will go to lindir this time, okay, not lindir2, and I type ls. You can see dir is existed as well. So you can see that any modification, I create files, I create something, I delete something, actually anything here inside lindir2 will be referred to lindir2. By the way, lindir2, because we created as a soft links or asymmetric links, actually they are a shortcut to the lindir, which means that this is just a pointer to the lindir, not a copy. On the other hand, the hard link is something else. So if I go back here, you can see that lindir2 is now inside, or the same thing as lindir. Okay, now let's remove it. rm-rf lindir, and let's delete the lindir. But before I delete it, actually I want to show you something. So actually, if I go to lindir2 like this, you can see that I am inside the lindir2, and actually the lindir2 is the same as lindir. We saw that because after we created this directory, the same directory is created there. Actually, it is the same directory, not something new or something copied. Okay. Now, what if I want to go? Let's clear the screen first. Sorry. So, what if I want to go to the actual, not the link? By the way, you can see that now it is a bright blue here. As you can see, the color is different than the color here, which means this is a list. And if I go to it, we saw that we are inside the lindir2. But what if I want to go to the actual directory, not the, so by typing ls-l, I mean I don't need to go to lindir2, I need to go to the actual directory, which is the home Ubuntu lindir. How to do that? We will use the cd-p option, and then I will go to the lindir2, and actually p option or p capital, sorry about this. So you can see that p option with a capital P and go to lindir2, it will go to lindir, which is the physical actual directory, not the linked list or the copy from it, because you know that this is a linked list, a symmetric linked list that referring or pointing to the lindir. We will go directly to the actual or the original directory, which is the lindir. And as you can see, yeah, we are inside the lindir. All right. Now we learned about the symmetric links. Now let's learn about the hard link. So actually the hard link is the same format, but without using the -s option, as you can see. So symmetric -s, hard link without -s. Okay, so source destination. The source is remoting to jar, and again the directory doesn't accept hard link, just a soft link. But the regular files, yeah, accept that. It's okay. So here I want this remoting jar. I want to create a link from it, so it will be referred to this. But actually, it's better to have a text file. Yeah. So I will use the touch command, or let's use this command. Actually, it's good to practice that. So echo hello, and I will use the redirection. Don't worry about these. We will talk about these in details, but follow me for now. Actually, so t.text. Okay. All right, let's clear the screen and let's see. Now we have the t.text. If I cat it or concatenation, using the concatenation, yeah, we have the hello inside it. Now ln t.text, and it's better. We saw that it is better to put the absolute path. Okay. But by the way, it works. Even if you didn't provide the absolute path, it works. But sometimes it will give you infinite loop. So, and actually this is a bad practice to put a relative path inside the linked list. Sometimes it worked, but I don't prefer it. From my personal opinion, I don't prefer the relative path for the linked list. Okay, either hard link or soft link. So yeah, t.text. Now this is the source, the destination. It will be the same. Home Ubuntu t2.text. Okay, which is the linked list. All right, ls. Now you can see that we have t and we have t2. Okay. So if I remove the original file, either as let's try as a linked list soft link or as a hard link. So let's remove -rf, the lindir, which is the one we created, and this is referring or pointing to it, ls-la or let's clear the screen, sorry about this, ls-l, you can see that lindir2 is now read, which means that this file couldn't be found. So if I type ln dir2, or sorry, let's go to ln dir2, you can see that no such file or directory. Okay, because this file is not exist anymore, but it is existed. You can see that it is here, but we cannot go to it because lindir2 that was pointing to lindir is not existed anymore. All right, but on the other hand, the hard link, so let's have a look here. If I remove the t.text, okay, not the t2, and if I type ls, you can see that we have it here, ls-l, we still have it not read. So if I cat it t2.text, you can see that, yeah, it is hello as well. All right. So you can see that the soft link is something like the shortcut. In Windows, it is the shortcut. Okay. If you are coming from Windows, I mean. But here, the hard link is no, it will create a copy, the same copy from the file. It is just like the copy. It will create a copy from it. And if the original is deleted, it's okay. So you may ask me, but what is the difference? What is hard link? What is the difference between copying the file or the hard link? Okay, for the soft link, we saw. Yeah, it is just like the shortcut, and yeah, it worked. If we removed the original, it will be removed or it will be read like this. But the hard link, actually, no, it is not like the copy, because any modification on the original or any modification on T2, it will be applied to the original. Okay, let's see. Let's see again. Let's clear the screen. Now let's remove -rf T2. We don't need this file actually. Let's create another file. Let's remove directory lindir2. It's okay, we didn't need them. Now let's create this file. Okay, this time I will use the touch command, which is t1 or t.text, and inside it I can put this command or this thing. This is t.text. Okay, I will use redirection. Now please don't get confused. Again, I will talk about these later on. Okay, so t.text like this, and if I cat it, let's see what inside it. Yeah, we have this is t.text. Okay, so far so good. Let's clear the screen, and now let's put ls. Now let's ln home ubuntu t.text. Sorry about this. I pressed enter by mistake. Now here home ubuntu and t2.text. Okay, so we are creating a hard link from this regular file or text file. The source is t.text, and we saw what inside it. This is t.text, and here we have the t2.text, and let's press enter. Let's ls here. We have t and t2. If I cat the t2, we already saw what inside t.text. This is a t.text, but here this is t.text as well. Okay, so far so good. All right, you may ask me, but this is the same as the copy. Yeah, okay. Now if I edit the content of t2 I will use Vim for now. Don't worry about Vim. We will talk about it in details, but for now, just follow me. All right. Okay. So t2.text, and here inside it, I will put another line. Okay. And let's save this. Okay. All right. Now let's cat t.text, not t2.text, and let's see. Yeah, you can see that we edited or we modified t2.text, but the modification has been applied to the t.text, which is another line, which means that t2 and t, they are connected together. So any modification happens on t2 or t, they will be applied to each other. So again, this time let's modify t.text, not t2.text. So t like this. Let's modify third line. Okay, whatever. Let's save and see. Now let's cat t2. We modified t.text. Now it's time to see t2. Let's see. Yeah, third line. So you can see by practice that t2 and t, they are connected together. But the difference between soft link and hard link is that soft link, if you remove the original, and we already saw that by doing this practice on the directories, which is lindir, what we saw. But the hard link, no. If you delete the original, the T2 or the hard linked file, it will be stand still. It will not be removed, and it will be working as fine it's okay. Cool. Thanks for watching. I will see you in the next. Now, file and directory permissions, and this lecture actually is very important. So after executing the command ls-l, we have this following. You can see that this string, what are these strings? D, what is D? RWX, what is this? Dashes, what are those? This number, what is Ubuntu? What is Ubuntu here? What is this number? What is this desktop or whatever? Now, actually, this desktop, this is the folder, and this is test.txt. This is the name of the file, okay? But you can see that it has a lot of attributes and details. So here, these ones on the left, as you can see, these indicate is the nature of the file and the type of the execution or the permissions for these. So you can see that this directory, the desktop directory, it has D, which means this is a directory. But on the other hand, the test.txt here, it has dash, which means this is a regular file. Of course, we have other types like links, special file, symbolic link, all of that, and so on, etc., etc. Okay, these are the type of the file or the directory. Okay, this is directory and this is a regular file. R, which means read, write, execute. Okay, this is for read. This is read, and it has write and it has execute. But these for what? These are for the owner. Which is the owner? This is the Ubuntu user. The Ubuntu user is the owner of this file, or the owner user of this file. And the Ubuntu here is the group owner of this file or this directory. Okay, so the owner, the user, and the group. So the owner user is Ubuntu, the owner group is Ubuntu, and this, the first 3 bits, these for the owner, the second 3 bits for the group owner, and the third 3 bits is for like the others. Okay, so for example, we have user called John. It will be included under these 3. Let's have the other example, that is the text here. We can find that it is read, write, execute for the owner, which is the Ubuntu, correct? For the group, what is it? Correct, you are right. That it has only read and write and no execution, as you can see, for the owner. For the others, what it has? Correct, it has read only. So you can see others can read this file, read only. They cannot modify or something like this. Okay. Now don't worry, we will talk about these in details, a low level details in the few slides and in the next lecture, in the hands-on. But for now, keep that on your mind. This is another example, the file.lnk. So you can see that the file type here actually is L, which means this is a linked file. So, okay, I want to ask you a few questions. You can pause the video and see yourself if you can answer or not. So what is the owner of this file? Correct, it is the Ubuntu. What is the group owner of this file? Correct, it is the Ubuntu. Okay, now what is the permission for the owner group? Yes, it is read and execute only. As you can see, the first 3 bits for the owner, the second 3 bits for the group, and the third 3 bits for the others. So what are the permission for the others? Are they allowed to use this file? No, they are not allowed. Correct. Now, don't worry. We will talk about each of these parts, all values, all numbers, names, etc. in the next few slides. No worries at all. So you can see that there we have 3 different types, as we mentioned before. The D for directory, dash for a regular file, L for link or symbolic link. Okay, we already mentioned that. And also we have 3 different permissions: read, write, execute, R for read, W for write, and X for execute. Okay, and now what is the permission for files versus directory? Now again, for example, the execute for file is different than the execute of directory. So it will be like this. R, which means for as binary, this is to allow files to be read. Okay, this is for the file. But for the directory, this is to allow files inside directory to be read. So This means that this directory or folder, anything, any file inside it, it will be read. It can be read. But the file, this is to allow the file itself to be read. Okay? Now the write permission for the file to allow files to be modified. So for example, a text file, you want to write to it and add new extra lines. This can be if it has the write permission. But the directory, this is to allow entries inside directory to be modified, which means if you want to create new files, copy files to this directory, create new files on this directory, this is the write permission for the directory. But the execution here is as 1, as you can see, as the binary. And this is to allow files to be executed. Okay. So for example, we have .python file, .java file, .c++, etc., etc. .sh, which is a bash script file. Don't worry, we will have that in details later on. Okay, so this can be, if this file has the execution permission, it can be executed. But on the other hand, the directory, this is to allow us to go inside the directory using the cd command. So for example, we have a directory called dir1 or folder1, okay? And this folder1 doesn't have, for the others, okay, the execute permission. We cannot go to it. The others cannot go to it. Cannot use the cd command to it. It will give us a permission denied. No worries. We will have that in details, a low-level details actually, and you will understand everything in the hands-on lecture, the next lecture. No worries. But for now, please keep that on your mind. Now, the permission categories actually is the U, which stands for user or the owner. We have the G for the group, and we have the O for the others, and A for all, which means the owner group other or user group other. So what is the most important commands that we will use? The ls-l, this is to show us a long list command or long list format to show what is the current permission for this specific file or directory. We will use the chmod command. This is the change mode of the file or directory. And we have, for example, chmod 777. This is to change the mode of the directory to give us allow everything for everyone. Okay. Now again, please keep that in your mind as an example. Don't worry, we will have everything in details. What is the meaning of this and how to change a specific mode or specific permission for specific files or directory in details in the next lecture. But for now, keep in your mind that the first 7, which is the owner or the user, as we learned previously. The second 7 is for the group owner, okay, or the group. And the third 7 here actually is for the other. And as we learned previously from here, okay, that 4 stands for read, W stands for to or for write, and X1, which is stand for executable. If you sum these together, 4 plus 2 is 6, plus 1 is 7. So that's why it will has 7 permission, which means read and write and execute. This is the numerical way. Okay. Now again, don't worry. We will have another way actually, which is much better, or they are the same. Depends on what you prefer. How to change mode or permission for this specific file by using this command chmod. Now instead of using numerical way for this specific file, we will use the UGO. U stands for the owner or the user, G stands for the group owner, and O stands for other, equal read, write, execute. So which means that this file will have full permission, and this to assign this specific permission. By the way, with this command we can use plus to add an extra, or minus to remove specific command. Okay, to remove specific permission. Again, keep that on your mind for now. This is just a theory part. In the next lecture, we will have that in details, and you will practice with me step by step. We have the ID command. This is to print real and effective user and group IDs. So you can see that what is the current user that running this specific command. So also we will use the groups. This is to print the groups a user is in. So for example, I'm using Ubuntu user, and when I type the groups, it will show us what is the current groups or groups the name of space, the name of the user. For example, groups John. It will show the John's groups. chown to change the owner of the file and the group as well. chgrb or change group ownership. This is to change the group owner. And these commands are very important actually. Again, we will have these in details in the next lecture, the hands-on lecture. Now, in Linux, we have a special permissions as well, not just read, write, execute. So these permissions allow the file executed to be executed with the privileges of the owner or the group owner as well. So for example, we have the S small or S capital instead of the X bit. Okay. So S here actually, our file directory already has X bit when it is S small. But when it is S capital, this means that it doesn't has X bit, executable, not allowed or set. Okay. Again, I know you are getting confused right now, a lot of information, a lot of things, but no worries, just focus and just follow me. All right. For now, just follow me. No worries. So keep that in your mind. We have two special permissions, S small and S capital. When it is S capital like this, which means the executable permission is not allowed or is not here, which means dash. But when it is S small, which means that we have executable bit here. As well, we have T small and T capital. Okay, so T small, which means that directory already has X bit. These and T capital, which is directory doesn't have X bit, executable permission not allowed. Now S for regular files and T for the directory and folders. Okay, or the directory, they are the same, by the way. Directory and folders, they are the same, but different name. You know, we already mentioned that. Directory for Linux, folder for Windows. Just a name. Now, there are three special permissions as well. The SUD, the setUID, the SGID, the setGID, and sticky bit. Okay? So SUID here is a special permission assigned to file. These permissions allow the file being executed to be executed with the privileges of the owner. So for example, if a file was owned by the root user and has the setUID bit set, which is the S bit as we saw here, which is the S1, okay? And so this means that this file, no matter who executed the file, it would be always run with the root user privileges. And this actually is very important and very crucial file. So for example, you have a file, a bash script file, .sh file, has the execution bit or the setUID bit assigned to it. For example, which is the S command here, the S small in that case, because we need it to be executable after all. So the S is executable, which then, and the owner is the root. So this file will be run as the root user, even if I am running it using Ubuntu user or using John user, whatever. So this will be run as the root user. So this is what is the meaning of setUID or SUID permission. We have the SGID, which is when the set group bit is set and execute run to the authority of the group owner. So for example, if a file was owned by the user group, no matter who executed, it will always run with the authority of the user's group itself. So for example, the owner group is root and you execute this file using the Ubuntu user or John user or group. In that case, actually it is group. So actually it will be run as the root. It will not be running as Ubuntu user or John user. Okay. Finally, we have the sticky bit. So when the sticky bit is set on a directory, only the root user or the owner of the directory and the owner of the file can remove files within said directory. So for example, this is something very common in the temp directory. You can see that we have a lot of users in the system. For example, 10, 100 user, for example, 200 user, etc., etc. And you want this user to never remove other people files. So you will set the sticky bit for this directory. So any files inside this directory will not be removed by other users. Only the owner of this files can remove its own file, or the root, by the way. Okay, the root, of course, it is the admin. It should remove everything and control everything. So by this way, You will make sure no one can go to other people files or remove other people files. Okay. Now let's have examples for the Linux special permission and how to provide this actually. So how to provide the S sticky bit, or the S small S capital, or the T small T capital, which is the SUID, GUID, sticky bit. How to actually to do that using the commands, the regular commands we want. Now this is an example. chmod, as you can see, not 777, it is 0777. So this to give a full permission but with no special permission at all. We have the chmod 4, which is the full permission but with setuid bit. Okay. We have 2. This is to full permission but with setgid bit. As you can see, 4, 2. Then what do you expect the third will be here, which is 1. Correct. chmod 1 777. This is for permission with sticky bit. Now I want to ask you a question. How to provide a permission with setuid, setgid, and sticky bit? Depends on what we learned previously. Yes, correct. We will use chmod 7777. Okay. So this is actually, it will give a setuid, a setgid, and sticky bit permission for this specific file or directory. By the way, keep in your mind the sticky bit is for directory most likely, and setuid, setgid is for files. Okay, but for now keep that in your mind. Don't worry. I know you a lot of information, a lot of data here. I know. Just keep focus with me and keep that in your mind. We will have all of that in details in the next lecture. Okay, the hands-on lecture. By the way, we can use another way, actually not the numerical way here. You can see that we can use the UGO, which is the owner group other, plus S, which means that increase the special permission setuid, setgid. So this will add a special permission for this specific file, setuid, setgid for this specific file or directory. Okay, and we can use the T as well. As you can see, this is to add a special permission, the sticky bit as well. Thanks for watching. Again, in the next lecture, we will have all of that or all of what we learned in details. So don't worry. I know a lot of information. I know you got confused. Okay, now what I recommend you to do actually, I suggest you to re-watch this lecture again. Okay, so for the information to be fresh and to get all the information from this lecture, the theory lecture, and you will be ready in the next lecture, the hands-on lecture, to start practice with me step by step. Okay? Okay, I will see you in the... Now, let's put this command, and you can see that we have the long list format. Now, it's time to talk about all of these. Well, actually, not all of them. First now, let's talk about the first part, which is this part. And what is this? What is this? Okay, now you can see that we have the first part, which is this. Now we have this symbol, which is D, or this letter D, or minus dash, let's say, or sometimes it's L or something else. What are those? Well, actually, this is the type of the file. So here, as you can see, dir1, remoting, these are D, which means directory. Okay, now the slash here, or sorry, the dash here, as you can see here for this or this text file or this T2, these are a regular file. Okay, now if we have a linked list, so let's have a linked directory. So link dir2 to dir2, anything, it's okay. Let's have it as a symbol or as a symmetric. Now if we go have it again, now we have L. Okay, now this is just arbitrary link. Okay, so now we have L. L means a link file. Okay, now actually there are other files like pipe, special files, a lot of things. You can read about it, but these are the most important ones: the directory, the text files. We have the linked files or linked list files. Okay, all right, so far so good. Now it's time for the part 2, which is these bits. Now what are those? As you can see, we have read, write, execute, or RWX, RWX, RWX. What are those actually? These are for the read, write, execute. R for read, W for write, X for execute. But we have them duplicates. What are those? Please, read, write, execute. Then we have read, write, execute, and then we have a third read, write, execute. Now, actually, these are for the user, which is the owner of the file, which is Ubuntu in my case here. The group, the second 3 bits, which is for the owner group or the group for this file or this directory, which is in my case as well, it is Ubuntu. And we have the read write execute, the third bits, which is for the others. Others, which means that any other user or group on the system can have either read, write, or execute, or the three of them, which is read, write, execute in my case. So anyone in the system can read and write and execute on this directory, which is something bad, I know, but just follow me. By the way, the root directory doesn't have this permission, only for the owner, which is the root owner. Not even for the group, no, only for the owner, which is something more secure, because only the root user can do whatever it wants with this specific secret file, okay? All right. Now, I want you to follow me. Now, how to change the permission for this file, okay? Well, actually, we will start testing on the dir one, okay? Or actually, let's have on t.text, okay? The first thing I want to remove the t2.text because they are a linked list, actually. So we don't need to get confused here. So ls -la or -l, we can have this on the t.text, okay? All right. Now, for changing the user mode, we need to use the ch mode, which is change mode, okay? Change mode, we have two ways of changing the mode. We have the binary mode or the numeric number, or we have the second way, which is the letter mode, okay? Using the UGO. Okay, now we will handle both of way, so don't worry. So the first thing, let's have ch mode, then we provide the permission here, okay? Then we put the name of the file, which is t.text in my case, okay? Now, what are the permission? I will put, or I will start with the numeric way or the numbers way, okay? Now I will put a binary value translated or from the integer to give what we want, okay? Now, again, we have for the user and for the group and for the other, the user, which is the owner of the file, okay? Sorry for this file, okay? So the first part, which is the read, write, execute for the owner. Now, the read, it will give you 4. Follow me for now. The write, which is the W bit, it will give you 2, and the execute, it will give you 1. So it will be start from here, 1, 2, 4. So depends on what you want. Calculate and sum all the permission you want, then put the value. So for example, I want it to be read, write, execute. So I will sum 1 plus 2 plus 3, plus 4, which means 4, which means 7. 4 plus 3, which means 7. So 7. 7's mean read, write, execute. Now, this is for the owner. Now, let's start with the group part, which is read, write, execute. Another thing, I need it to be read, execute only. So I will calculate, or I will sum 1 plus 4, which is read and execute. Execute is 1, write is 2, read is 4. Okay, so 4 plus 1, which means 5. So it will be 5. Now, for the last part, which is the other part, I want it to be 0, which means no read, no write, nor execute. Okay, so it will be 0. So it will be 750. And now, if I type it like this, and if I type ls-l, and let's have a comparison between this one and this one. So you can see that here we have read, write without execute, which means dash. Dash here means no bit has been set, which means no execution. Here, no write bit, on here, no execution bit. But here, after we done it, now we have read, write, execute. So you can see that execute has been added. Read, execute only, which means the execute has been added and the write has been removed. And we have the dash, which means no permission at all for the others. But so you can see comparison with here, we removed the read as well. All right. So far, so good. Now, this is the first method. Now, it depends on you, what you want. So, read only, write only, execute only, read, execute, read, write, execute, write, execute, write with read with only, execute only, whatever you want. Put whatever you want, depends on that. Put ch mode, put the permission you want, 555, for example, and the name of the file you want to change the permission for. Okay? Okay. Now, this is the first way. Okay, ls-l again. Now, the second way, which is using the letters way. Now we will have the UGO, which means user group other, and we will use plus minus equal, and then provide read write execute. Okay, and we have the S, but the S, which is the special permission, we will talk about it later on in this lecture, don't worry. All right, now actually this is the most preferred way that everyone use it. They will not use the binary way, they use this way because this is much readable, human readable actually. And actually, from my personal opinion, I use this. Again, it depends on what you prefer and so on. So yeah, you prefer that way, you are used to that way, it's okay. Or you want to get used to that way, it's okay. But from my personal opinion, it's better to have as simple as possible, because when things go down, when you, for example, you are a DevOps engineer on this company and this company servers is going down and you want to change a permission or you want to do something, so it's better to have a simple approach, because the errors or the human errors will be less than when comparing if you are using a complex way. Okay, well actually this is my personal opinion. After all, you choose what you want. Okay, now let's start. For example, now let's see, have this t.txt file. We have the read write execute, read execute, and we have nothing for the other. So for example, I want for the user to have the read write execute and the group to have read execute and the other to have execute. Now actually I will talk about it this fast. So the first thing, the U and G and O equal read write execute. So this will give you, as you can see, we have equal, we have plus, we have minus here. Plus add, minus remove this, equal, it will be absolute like this. So t.txt file, which is the name of the file. Sorry about this. Yeah. So chmod, the user or the owner, the group and the other equal read write execute, and let's have it here. So if I type ls-l, you can see that this time it is read write execute, read write execute, read write execute. All right. Now actually we can have it again, which is chmod ugo, this time minus read write execute, as you can see, and put the t of text, which is this time the user and the owner, the group, remove the read and the write and the execute. So let's put it like this, ls-l, and you can see that the t.txt file has no permission at all. All right, so far so good. Again, chmod ugo plus read execute, oh sorry, without space here, plus read execute to the t.txt file. Okay, so this will give us only read write for everything, which is this one. Let's clear the screen and let's have another look. Well actually, instead of using the ugo, because you are writing to everyone, to all, you use a equal read write execute to the t.txt file. Okay, now let's have a look. Here a means all, everyone, so the user, the group, the other. So if you look here, yeah, this time instead of read write only, it will be read write execute, read write execute, read write execute. So far so good. And for example, if you want the other to be nothing, okay, so you can just type other minus read write execute t.txt. So this will remove the read and write and execute from the text file. Sorry, I forgot to put the chmod here. Sorry. Yeah, chmod. The other will be no read, no write, no execute, as simple as that. And if I type it here, you can see that it is very simple. Now actually it is better, I will not handle every situation here or every case, but it's better to have a real hands-on. Please open your terminal, get your hands dirty, and try everything possible for this temporary files, whatever file you have. Now enough with that, let's talk about another subject. Now I want to talk about what is the difference between the directory and the regular file as a read or write or execute. So as a read, yeah, the text file is readable. So let's have a comparison between t.txt and let's make a directory. Let's name it dir ls, for example, or dir1. But for that, let's remove dir1. And let's remove dir2 as well. And let's put the -rf. So ls-l. This time we don't have them. Sorry, let's remove the dir2 as well. So you can see that we don't have them. Let's make another directory and let's name it dir1. Okay. So let's have a here. Look, yeah, dir1, and we have t.txt file. Okay. Now, for the file or the regular file, which is t.text, readable means I can concatenate it, I can echo it, I can open it using any text editor, okay? So you can see that it can be readable. So if I t.text, you can see that we have this arbitrary lines or arbitrary text, whatever, okay? But if I removed the permission from everyone, which is all minus R, okay, I will remove the read permission. By the way, you can, instead of a minus R, you can put just minus R and the t.text. This will work as well, okay? So if you have a look here, nothing is readable. T.text is not readable. So t.text permission denied. Even though you can see that I am the owner of the file. You can see that Ubuntu, I am the owner of the file. By the way, this will not work on the root user. So if I type sudo cat, and don't worry about the sudo, this we will talk about it in a separate lecture and full details about the sudo, what is. But for now, keep in your mind, sudo is used to run specific command as another command, as another user, which is in my case as the root user. So I'm running the cat as the full permission user, which is the root user, cat t.text. You can see that even though you can see that no one has a read bit enabled, you can see that the root user, which is by doing this command, is able to read the file because this is the king user, which means the full permission user. It can read anything, can do anything. He's the owner of the system, you know. So that's why it's very dangerous to have him or to have this user compromised. Anyway, let's return back. All right. So we saw what means the read for the t.text. So chmod, again, let's put, please increase the read for the t.text or a t.text. It's okay. A plus read for the t.text. It's okay. It will do the job. All right. Let's clear the screen and put ls-l again. Now, this is readable for the read file. Okay. For the write file, it is the same. So I can write content to this file. By the way, this is depend on the either the owner, the group, or the other. So if I have for the owner read, but without write, and on the group I have it as a write, or on the others I have it as a write, well, actually the owner will not be able to write on the file, but the others will be able to write on the files. By the way, this doesn't make sense, I know, but just keep that in your mind. Okay, so for a regular text file, the read to read the file, the write to write to the file or modify the file, and execute if you want this file to be executable. So you are writing a bash script, Python script, PHP, whatever. So you want it to be executable. Okay, now this is the first thing for a regular text file. But for a directory, okay, this is different now. So for the read, yeah, it is very simple. You can read the content of the directory, which means what are the directories inside it, what are the regular files inside, and so on. For the write, very simple. You can modify the directory. So you can create new directories inside it. You can modify its name. By the way, modify, which means modify its name, modify the content, either in a regular file or a directory. Okay. And we can create a text file inside this directory, which is the writable, which means this directory is write. But finally, what is the execute bit for the directory? We know that what it is for the regular file. The regular file, which means this file is executable to execute commands, bash script, Python, whatever. But for the directory, the executable actually is go inside it. So execute a specific directory means I can go inside this directory. Now let's see, have this here. So let's have chmod execute. Let's remove the execute from everyone on dir1. Okay. So ls-l. Now we don't have any execute permission on dir1. So if I try to go inside it, even though I am the owner of this, you can see that permission denied. All right. So even if I type ls, by the way, you can see that it is readable for everyone. Where it is here. Yeah. It is readable for everyone. Other, owner, the group, whatever. Dir1, you can see that I'm able to read what is inside it, but I cannot do or create anything inside it. So if I create a directory, or let's create a text file, or directory anyway, let's create a directory inside it. So let's name it dir2, but this time we want it to be inside dir1. So yeah, you can see that permission is denied. Why is that actually? Even though I am the owner, which is Ubuntu, as you can see, I am Ubuntu, and I have a write permission. You can see, even my group have write permission, but you can see that because I am not able to go inside it, because actually under the hood, make dir command, what is this command do actually is go inside the directory, which is dir1, and then we create a directory called dir2. So that's why I don't have the permission to go inside the dir1. Okay. Again, by the way, if you are using the sudo or the root command, the sudo command with the root permission and privilege, you are able to do whatever you want. Okay, because this is the king on the system. It can do anything you want. All right. Now we have talked enough about the permission. Now we didn't talk anything about how to change the owner or the group of this file. Okay, actually we have two commands. We have the chown. This is to change either the owner or the group, by the way, or the group and the owner. And we have the change grb, which is change group. Okay, and this is to change the group of this file or directory. Okay, let's try have a hands-on real quick. So chown. So this time I will choose another user. Let's name it test, for example. Change owner test to the t.text, but maybe this will not work because actually the test is not a real user actually. So I want to change it this time for the root user. Okay, so if I type root, you can see that operation not permitted. Yeah, how can you change to a root, which is the king user? So you can't do that actually. So you need a permission for that, and you need to provide the sudo command. Okay, and by the way, I have this shortcut for you. So instead of typing this and type the sudo command, you can type the sudo shift11, which means the exclamation mark, and here to run the previous command, which is this one, which is change root to the t.text with sudo permission. And if I type it here, you can see that yeah, it worked fine, which is, and it print what is the previous command, which is sudo chown root t.text. And here, yeah, you can see that t.text now, as you can see here, previously it was Ubuntu, but here it is root. So if I try to read it or do whatever I want, so actually maybe I can, because I am the group after all. Here you can see that I am inside the group, the Ubuntu group. Anyway, who cares? Let's say, yeah, you can see that I am able, even though the owner is the root, but maybe because it is have other permission to read the file. Anyway, no big deal. Now what if I want to change? Let's clear the screen first. I want to change the owner and the group, or the group. So grb and root. By the way, every user created on Linux has a group. So Ubuntu user have a group called Ubuntu group as well. Okay, so root user has a root group as well. So root change group, as you can see, change group root for the t.text file. And of course we need a permission, so sudo shift1, which is exclamation mark. And yeah, so if I type it like this, you can see this time the owner is root and root. Okay, now what if I want to change this root and the group root with one command? I don't need that. So actually I need to provide sudo chown this time. But you may ask me how to do that. Yeah, actually you put the name of the user. We already saw that. And in my case, I want it to be Ubuntu. Or you put now the colon, then provide the Ubuntu as well, t.text, which is the name of the guy. This will change the owner, which is the user, and the owner group, which is Ubuntu. And actually, from my personal opinion, it's better to have chown because it is much newer than the chgrb. But it depends on you what you prefer. Everything will work. No performance here, nothing security. It will do. It's just your preferences. Okay, so let's have a look here. Yeah, you can see that I am able now to change the owner and the group of the t.text, and it worked fine. Okay, now we have another command, which is the id. So actually id here, if you can see, if I type it here, if I type man id, you can see it will print the real and effective user and group id of the current user. So the current user I have, which is Ubuntu. If I type ID, you can see that this is the user ID, which is 1000. This is the GID, which is 1000. The groups I am in, which is Ubuntu, and this is the GID for it, as you can see. Here are some of the information, some of the groups I am inside it. So you can see that I am inside the sudo group. Don't worry about the sudo. We will have a detailed lecture about it. Don't worry at all. And here are some of the other groups for the system. Actually, it doesn't matter. Okay, so you can see that by typing the ID, we know what are the group the Ubuntu is inside, which is Ubuntu, ADM, dial out, whatever, CD-ROM, floppy, sudo, which is something very important. We will talk about it. Don't worry, and a lot of other things. Okay, now actually we have another commands, which is the groups. So you can see that we have the groups like this. So you can see it will print only the groups that user or the current user, which is Ubuntu in my case, is in, which is Ubuntu, ADM, dial out, CD, floppy, sudo, audio, blah, 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 whatever. Okay. All right. So far, so good. Now, one last thing I want to mention here in this lecture. I know the lecture took too long time, but actually these are the most important things in the Linux, which is the permission. Well, actually not the most important, one of the most important. All right. So, which is the special permission? Okay, so let's clear the screen first and let's ls-l. Now, for the special permissions, actually, we have three special permissions: the SUID or the set user ID, the SGID, which is the set GID, and we have the sticky bit, which is the sticky bit for the directories only. Now, let's have a look. Don't worry, we will have that in details. Now, the first thing, actually, how to implement or how to apply these permissions, actually using something we already use, which is the chmod. Yeah, and you need them for this file, which is t.txt. And when you need them for what? For user or group or other, let's use them for all. So all equal. Or let's put plus, which means increase that. Okay, we already learned that. I'm assuming that you are familiar now with the chmod command. Now, this time I will not use read or write or execute. This time I will use special letter called S, either small or T small. Now, S, let's start with the S first, then we will go the T, don't worry. The S, which means the special permission. Okay, which means the special permission for the SUID or the group ID. So I plus S to the t.txt. Now you can see that we have them here. If I type here, yeah, you can see that it is now red, highlighted in red. And you can see that the RWS, not RWX. You can see previously it was RWX, and now it is write WS. And again, it is read, write, execute for the group. And here it is read, write S, which means special. All right, now you can see that it is small. Why it is small? What is the difference between the small and the capital? Now, the small, which means the execute bit is set, which means that this group is executable and it has the special permission. Okay? And here, the same thing for the user, which means the special permission is set and it has the executable enabled for the owner. Now, what are what are the special permissions? Now, to be honest, the special permissions, as simple as that, it is just run this file, and actually it's better to have an executable file, to be honest, not for a regular file or a text file just to read or write. No, actually, these are worked actually exactly the use case for the executables files, either executable files or executable directories. So executable files, in my case, let's imagine I have a bash script here or Python. So which means run this file as the owner, which means as the privilege of the owner. So imagine if this is a root owner and run this file as the owner, which means run this file as a root, which means this is a very huge security breach, or on the other hand, it is something you already used for this purpose. Okay, so you need to be careful here because this is something dangerous. If the owner is root, you need to be careful here. Okay. So this means that anyone can execute this as the root, which means it has the privilege of executing root commands, which means you compromise the whole system, which is something very dangerous. Now, for the group, it is the same. You can see that we have it here, which means run this file, this executable file. Let's imagine it is a bash script. Okay, run this bash script as the group owner, which is not the owner only, or as a group. So which means that it will run first as owner and it will run as a group as well. Okay. By the way, there are precedents here. The first precedence for the owner, then the group, then we have the other. Okay. Anyway, now you can see that on the other part or the other executable here, it is not. All right. Now, but before that, let's put the same command, which is a plus s, but this time I will put s capital, which is as this. You can see that, yeah, it give me error. Okay. Now, if I press minus, it will give me error. Okay. So how to do that? Which is minus x from t, from everyone. If I type it like this, if I type s-l this time, you can see that now it is s capital, not as small, which means the executable bit under it or inside it is set to off, which means it is dash like this. Okay, but previously you can see that it is s small, but now it is s capital, which means s capital, the executable bit for the group or the owner is set to no, or set to null, or no executable bit are enabled. Now the last thing, let's talk about the sticky bit, and actually this is only work on the directories. Okay, so how to do that? chmod a, let's assume it's a plus. Now this time I will not use s, this time I will use t. By the way, a t capital will not work as this s as well here inside this chmod, so you need to remove the executable bit from it. Okay, so let's add that sticky bit for the dir one, and let's have a look here. Oh, cool. So you can see that now it has, and by the way, it is t capital as we mentioned previously in the s case here, as you can see, which means that the executable bit is set to 0 or none, which means that no executable bit here. Okay, now if I type chmod let's say other plus executable, and we want for it for the dir one, and let's have ls-l, you can see that it is not t capital this time, it is t small, by the way. And again, what are the sticky bit? We already learned what are the SUID or GID, which is for the user or the group, and actually these are for the directory, for the regular file, actually for the executable file as well. But for the sticky bit, it is only for directories, and this means that only the root user, which is the king user, or the owner of the file can remove this file or this directory. Actually, this is only work for directories. And where it is that in the system, you can see if you go to the temp directory. So actually, let's clear the screen, ls-l for the temp directory. You can see that we have it here. So you can see that, sorry, I need for the temp directory itself. So if I type it like this, actually, you can see that it has the t permission, which is the sticky bit, and it is executable because it is t small. Okay, so this means that only the root or the file owner on this directory, which is /temp, let's have a look here. Actually, it's good. So which means, for example, this file, only the mapper user. For this file, only the root. Yeah, by the way, this is the root only. For this file, only the Ubuntu user can remove this directory or remove this directory. Only the mapper can remove this directory or the root, by the way. And here, the same thing for the Ubuntu mapper and as well. Okay, so this is what sticky bit are. Sorry for the long lecture, but actually it is very important. If you didn't understand, you can ask me question, or you can read the theory part again. You will understand everything there. Thanks for watching. I will see you in the next lecture. Alright, now it's time to talk about how to find a specific files. Okay, so in this lecture, we will use two commands. the find command and the locate command. Okay, now let's start with the find command. So let's have ls here. So let's make this text file, which is t.text. Let's use the touch command. Touch command will create a text file for you. So here, echo. Let's put whatever value. It's okay, nothing big deal. And use the direction. Don't worry, we will talk about these later on. No worries for now. So echo this and put it inside the t.text. Okay, now let's clear the screen and have ls here, so will be more clean. Now, I will use the find command. Now, I want to search in the current directory, which is dot, or where I want to search for this file. So, for example, slash, which means root, or slash home, okay, or whatever file I put here, the absolute path, okay, or the dot, which is the current path, and this means that find dot dash name. So this is the name of the file, which is t.text, and let's press enter. You can see that, yeah, we found it, and this is the path for it, which is dot slash t.text. The dot means the current directory, which is, if I type baud, which is home Ubuntu, okay? Now, if I found, or if I put t, but this time the t is capital, you can see we cannot find it, right? So to do such a thing, or to remove such a thing, we will use the I name, dash I name, not dash name, which means ignore the case. So if I type here, yeah, we found t.text. We ignore, as you can see, I, which means ignore the case. So far, so good. Now, what if I want to do specific things with this command, okay? Sorry, with this file that we found. So for example, the output dash ls, which means print the output as a list format. But by the way, this is the ls, which is from the find command. This is not the system ls. Or I think under the hood they use the ls, but they add specific things at it, like this one or this things, whatever. Okay. Now, what if I want to execute commands after I found this file? So for example, I am searching for temporary files, and these files I want to delete them. So how to do that? I will use the exec option. So dash exec and put whatever option you want. So ls-l, for example. This is the commands I want to execute. And don't forget, we put the braces here, or the curly brackets. Then backslash dot. Okay, enter. You can see that, yeah, we found it. This is the file. And the last modified, the user, the group, the permission, and whatever. Okay, so actually we execute the ls command for this file that we found, or these files that we found. Okay, so for example, so let's have t1.text. Okay, let's create t1, t2, t3. Okay, and if I found it again here, ignore the cases. We only find one, of course, because we are using the t.text. Now, what if I type instead of .text the wildcard or the arithmetics, shift 8? So like this, you can see that we have found 1, 2, 3, 4, or the t.text. All of them have been found, okay? Because star means here everything possible, which is the wildcard. Well, I'm assuming that you are familiar with that. Anyway, so let's clear the screen and let's ls-l. Let's see what we have. So, for example, these are temporary files in the system, log file, for example, or system errors, or something. I don't need them. For example, I want to archive them, and we already have a process archiving that, but I want to delete them. Well, I'm just assuming this is the case. By the way, all of that can be handled by the cron job. You don't need to do that manually. Actually, this is something automated, can be done, or Jenkins or whatever. But anyway, don't worry about the cron jobs. By the way, we will talk about it. I want to find dot dash I name, and the name is t star, which is anything, and I want to execute this command, and this command this time will be rm-rf, and put the curly brackets slash dot. Okay, like this. So if I type this, sorry, maybe I forgot something. So yeah, it will be like this. If I type like this, yeah. Did you know why this happened? So actually, let's have this time ls-l and see why this happening. because you can see that there is something here. Ignore the cases here. If I took T capital this time, so you can see that the problem is with the T small. So if I type -I name, I need to provide the T as a capital or the letters as a capital, which means either capital or small. Okay, this is how find command work. Okay, so it's clear, and let's have another look. This time I want to remove. All right, so rm-rf. So let's have a look. You can see that there is something here. Yeah, we already delete that, but if you notice here, while we are searching, we looked for this and this and this and this, but we find this, which is total 0. So we don't need, so that considered to be not found. So you can see that the cache to temp or something, no such file or directory or whatever, it considered to be that. Anyway, you can see that we already deleted the files and everything worked correctly. Now the other command, which is the locate. Okay, so let's have another file, which is t.txt again. And sorry about this. So, and I will copy this file and put it inside the temp directory. But again, don't worry about the copy command, the move command, renaming the files, names or whatever. All of that will be handled in the next lectures. But don't worry. So for now, follow me. Copy from source to destination, and I will name it t.txt, or let's put it as is and let's put it there. So if I type the locate command t.txt, you can see that it will start looking for anything text. So here is the text, whatever, something, and you can see that if I look here, you don't know, or there are nothing called t.txt. Okay, so I need to provide another command, and this command called update db. So this is to update the database for the locate to be working. So sudo for the thing, and yeah, you can see that we already updated that, and now it's time for running the locate command t.txt, and you can see that this time, yeah, we found it. So you can see that it is here, the home ubuntu t.txt, but by the way, we can't find it in the temporary. Maybe he don't have access there, or I don't know actually, but anyway, we have it here and everything is working as expected. All right, thanks for watching. Okay, now we want to talk about the Nano, viewing files and editing files using the Nano editor. Now, the most important commands that we will use in this lecture, which is cat.txt or cat.tfile, cat.txt file. This is to display the content of the t.txt file. More.t.txt file. This is to browse through the t.txt file. Less t.txt file. Actually, this is a typo. This should be T here and T here, but regardless, this is the same as more, but with features more or extra than the more command. Okay, we have the head. This is to output the beginning of the t.txt file. By the way, it has options like the first 10 lines, the first 20, 100, etc., etc. For example, this is head-15 t.txt file. So this is to output the first 15 line of the t.txt file. And we have tail. This is to output the ending of the file. By default, it is 10, the last 10 lines. Or we can use the -15 or -n15 -n150 or whatever numbers we want. This is to output the last 15 lines. Tail-f, this is to open the file and output the ending of it, okay? Because we are using the option here or the argument -f. And Nano, this is to open and use Nano editor. So either to create a new file or to edit already existed file, okay? Now in the next lecture, we will talk about all of these in hands-on, step by step. I will see you there. Now we will start to talk about how to viewing files with more details or more options, okay? Now we learned about the cat or concatenation. So you can see I have this t.txt file. So cat t.txt like this, and it will print everything inside it, okay? So as you can see, because this is not a large file, so it print everything on the standard output without issue, okay? But for example, let's have this, which is one of the log file in the system.
auth.var whatever. Okay, so if I cat it, you can see that it print a lot of things, as you can see. Yeah, as you can see, everything has been printed outside, and we don't need that. For example, now imagine if you have 2000 line, for example, or something like this. So this is bad. So in that case, we will use either more or less. Okay, so if I type more slash var log auth, for example, you can see that not everything has been, nothing has been printed. So you can see more the var log auth whatever. Okay, but here we have only 18% of it. So if I keep pressing enter, you can see that 23, 30% and so on. Okay, until I reach the end. Okay, all right. Now if I press Q, it will quit from this more. Okay, now this is the same thing for less. So if I type less like this, var log auth dot something or dot log, you can see it is the same, but this time it is more flexible because I am able to use the arrow now. So you can see the right arrow, the left arrow, you can see that it is more feature. It has more feature. Actually, it has a lot of things. By the way, if I type or put slash like this and put, for example, UNIX, okay, and press enter, you can see that it will start highlighting every UNIX in the whole file. Okay, so I keep pressing enter, down arrow, up arrow, left arrow, right arrow, everything will work. Now to quit, just press Q and it will quit from the list. Now I want to talk about the two ways also, which is head and tail. Now head, actually, it will print the first number of lines, the first some number of lines, and the tail, it will print the end lines. You specify the number of lines. So head, by default, it will print the first 10 lines. So if I type var log auth like this, so you can see that we printed only the first 10 lines. All right, it is the same thing for the tail as well. So tail var log auth dot log, you can see that we printed the last 10 lines. Okay, now if I want to increase the head or tail, so I will provide the option dash which the number, so dash 20, which means the first 20 lines. Yeah, you can see that they are 20 now. All right, and the same thing for the tail, dash number of lines, so 100 for example, it will print the last 100 line. Now we have this option on the tail, which is the tail f or tail dash f actually. Okay, now var log auth, now this is but as it's being written to. So if I have this Nginx or Apache.access log and I want to see all the logs or all the error logs, for example, I will press this and press enter. As you can see, I am still in the on the tail program. I didn't quit from it. So any new logs or any new errors written to this file, which is var log auth, it will be printed here. Okay, and you can see it as a real time. All right, now finally let's talk about the nano editor. Well actually I don't prefer nano, I prefer vim. It's much powerful, it has a lot of features, and actually it comes almost with all systems. Okay, even if you have an older server, they don't have nano, they have vim by default, so you need to learn vim actually. But for now, just open nano. You can see that you can type whatever you want as a text editor. As you can see, visual text editor, and here Control X to exit, Control G to get help, Control read out, where is to search something, replace, as you can see, and cut text as a copy or paste, undo, redo. Actually, it is very powerful. I'm not saying it's bad, but I don't prefer it. All right, so if I want to quit, and no or yes, and depends on that, which you will save whatever you want. Okay, thanks for watching. I will see you in the next lecture.
Okay, now editing files in vim or by command or utility. Now, what is the difference between vi versus vim versus view? Now, vi stands for visual. It is a text editor that is an early attempt to a visual text editor, and it is one of the oldest text editor in the system, in Linux system. we have Vim, which stands for VI improved. Okay, it is an implementation of the VI standard with many additions. Finally, we have the view, which starts with Vim with a read only. So this will be a read only mode. Actually, this is a read only. Sorry, this is a mistake. Okay, this is a typo. This is a read only mode. So the view will not edit anything. Now, what is the most important Vim or Vi shortcuts? Now we have this, which is Shift plus 6, the hat, Shift 6. This is to go to the beginning of the line. We have $, Shift 4, go to the end of the line. I to insert at the current cursor position. I capital, Shift I small. This is to insert at the beginning of the line. A to append after the cursor position. A capital, Shift A to append at the end of the line. O here to insert a new empty line below the current cursor position. Colon with W, which is Shift semicolon with W. This is to write or save the file. W Shift 1. Okay, this is to force the file to be saved. The exclamation mark. Shift Q to quit without saving anything. This is to force quit. WQ, this is to write and quit. WQ to write and quit but with forcefully. And X the same as WQ. So exit and save and exit. With N, which is the position, the cursor at the line, specific line, which is 1, 4, 146, etc., etc. The $, the position, the cursor at the last line. GG, position the cursor at the first line of the first file. Shift G or G capital, position the cursor at the last line of the file. Set NU, which is to turn on the line numbering, so it will show us the lines, the number of the lines, I mean. Set no num or no NU, this is to turn off the lining or line numbering. We have with colon help, this is a sub command. They could help for that specific sub command. V for visual selection, so it seems like they're using the cursor to copy and paste. Y stands for yank, which is copy. D stands for delete, which is cut. Okay, this is cut. P, paste. Y, copy the current line. This is if you want to use without V, the visual selection. And U to undo. Okay. Now we have using the slash to search for a specific pattern. You put slash and then put your pattern. N for typing, enter for the slash pattern, then N it will search for the next. It seems like Control F, find the specific text, press enter, press enter. This is the same thing, but we'll use the pattern and using N. And capital, after typing enter of the pattern, then N will search for the previous. So N for the next, and capital, Shift N, it will go to the previous. And all of that. Okay, now in the next lecture, we will have all of that in details, step-by-step practice. Okay, don't worry. Okay, a lot of information, a lot of things. You are getting confused right now how to use the N capital and small pattern, all of these commands or all of these shortcuts, how to use them. Everything will be handled in the next lecture. I will see you there.
All right, now it's time to talk about the Vim. Now, actually, we have 3 utilities now, or 3 programs, the VI or Vim or View. So actually the VI is the same as Vim, but the Vim is improved and it has more features, okay? And the View, it will open any text file only as a read only, okay? So you have a secret file, or for example, so yeah, let's test on t.text. So vi or vi t.text, you can see that we open the t.text using the vi. But if I type vim.t.text, you will not see the difference here actually, because either actually maybe they are referenced to each other. So the v or the vi is the same as the vim. Actually, they are linked together, I guess. Well, anyway, we have the view, which is t.text. So you can see that here, you can see it is read only. All right. So if you are opening a configuration file, very crucial file in the system, you don't need to do any mistake, any stupid mistake. So you can just using the view t.txt. By the way, opening the file using vim or vi, whatever, from now on we will start using vim, okay? So you can see that opening any file, it is not readable as well. As you can see, I can't put anything. Yeah, but because I press the insert button or insert mode by mistake, but you can see by default, I can't put anything or I can't do anything. All right. Anyway, now let's start with the vim shortcuts. All right. But for now, actually, I want to open a large file. So let's open one of the varlog auth.log, whatever, okay, whatever files. You can see that, yeah, now it is highlighted. By the way, if I open that using vi, I think it will not be highlighted, I guess. Let's see. No, it is highlighted. Yeah, as I told you, the vim and vi, they are linked together. Actually, they're referring to the same program. All right. Anyway, now I am here. As you can see, I can use the left, right, up button, down arrow, and as you can see, it will work as expected. As you can see the cursor, I can choose it or move it wherever I want. Now, if I want to go to the first line, I will use the hat, which is the shift 6. You can see that I am on the first of the line of the current cursor position. So you can see that the cursor is here, shift 6, which is the hat, and you can see that it will give me, and it will move the cursor to the first of the line. Now, to go to the line, to go to the end of the line, shift 4, which is the $sign. So you can see that now I am at the end. Okay, so now shift 6, it will go to the first line, and shift 4, which is $sign, it will go to the end of the line. All right. Now it's time to modify and start with the inserting mode. Now we have the I small, I capital, A small, A capital, and O. Okay. Now actually these are the most important ones I put in the theory. So actually, if you read the theory part, you can see that I put a lot of options and shortcuts there. These are the most important ones, but this is not just Vim. Vim actually do a lot of things like replacement, a lot of things actually, but these are the most important ones. You can read more about Vim, by the way. So here, if I want to insert a line at the current cursor, you can see I will use the I small. I small, you can see that I am opening the file. But by the way, you can see warning, you are changing a file in a read only mode. Okay. So because this is, I think it is for the root only, can write on that because this is log for the system. Yeah, by default, that's for sure. But anyway, let's continue and we will test the writing, saving, quit without writing on a different file. Okay, but for now, I small, it will open the insert mode, which is typing anything I want, but this time at the current cursor. As you can see, if I press exit from here, currently I am on the N letter. If I press enter or press I mean, it will open here, as you can see, insert, and on the same cursor. Okay, if I press exit or escape, it will escape from the insert mode. Now the same thing with the I capital, which is shift I. Shift I, it will create or insert mode, but this time at the beginning of the current line. So the cursor is here, was here. It will insert or open the insert mode on the same or on the beginning of the line, as you can see. Press escape again, press escape button, and yeah. Now we have the A append. I means insert, either insert at the current cursor or insert at the beginning of line. A will append after the current cursor, as you can see, which is D. If I press exit again, currently I am on D. If I press A, it will append after the D letter, which is where I am. Okay, but if I press shift A, okay, it will give me A capital. It will append after the line. Okay, actually it is simple, right? I insert at the current cursor, or shift I, which is at the beginning of line. A to append on the current cursor, or shift A to append after the end of line. Or on the other hand, it will create an empty line for you, as you can see. Yeah, empty line, and you can put whatever you want here. Okay, so empty line after the current cursor. So if I am here, for example, if I press O, it will create a new empty line as well. All right. Now to save that, actually, we will use the shift here, which is shift with semicolon, which is the colon, I mean, colon with Q. Q to quit without saving. W to write or save. Okay. R, WQ, which is save and quit. Okay. Now, X, by the way, it will work as WQ as well. Okay. Now, if I want to quit, for example, like this, but you can see that no, you can't because you already modified the date or already modified the file. So shift with or like the colon Q. By the way, you can see that I am writing here. Did you see that? Yeah, which is colon Q, and now shift 1, which is the exclamation mark. So you can see that now let's quit without saving. Okay, the same thing for quit and with Q, the same thing for write. Okay, but write it will not work because if I type here, you can see that you can't open the file for writing because this needs a root permission. But so let's quit, but without saving. All right, like this. Yeah, worked 100%. Now let's open it again. Now you can see that I am currently on the line 17, 16, 14, 10, whatever. Okay, what if I want to go to line 100? So you type this and you put 100. Okay, so you can see now currently I am on the 100 or on the line number 100. If I go here 120, yeah, you can see currently I am on 120. Okay, now what if I want to go to the end of the line or end of the file? I will use shift and with shift I will use the colon, I mean, as you can see here, and shift 4, which is the $sign. This will go to the end of the file, as you can see. Now actually this is the same thing if I want to use GG. GG, it will go to the first of line. Shift G, it will go to the end of line. Okay, so it's up to you what you prefer. GG, first of line. Shift G, it will go to the end of line. Okay, or end of file. GG, the first of file. Shift G, it will be the end of file. Okay, now if I want to enable the numbering here, you can put this, the colon, set NU, which is number. You can see that currently I have a numbers here. Oh, so nice. Now set. So if I type no number this time or no new, which is it will give me no number. So set number, it will give me number. Set no number, it will remove the numbers. Okay, now it's time for the copying. So if I press exit now, yeah. Now I want to copy, for example, this line and this line or some of this line. What you will use? We'll use V, which means visual copying. So you can see now after that, you do that, you start moving the arrow, whatever you want. I want for that. Now I have copy, paste, or the cut, paste. Okay, so for the copy, we will use Y. Yeah, you can see Y, it worked 100%. 5 lines yanked. Y stands for yank. So why it is named yank, I don't know actually, but anyway. So now press P, which means paste. You can see that, yeah, it pasted correctly. But you can see that because I am currently, so let's go to the end of line, actually end of file, and let's open this and press this, press exit. Now press P again. You can see now, yeah, it has been pasted completely. Now again, if I press V and do whatever I want, I can use D this time, which is cut. So you can see it has been cut. And if I press P, it will paste again. So copy and paste, cut and paste. Now what if I want, I don't need to use the visual, I want to copy a complete line and paste it. Use YY. You can see that now it has been, let's use on this one actually, YY, and let's paste it here. You can see if this worked. Yeah, it worked 100%. Now what if I want to undo the change I done by using the U command or U button, I mean. U. Keep pressing U until you reach what you want. Now finally, what if I want to search this file? I will use the slash, as you can see, and put the value you want. For example, I want December, but you can see that it must be in case sensitive actually. Press enter. Now you can see that currently, yeah, it worked and it is aiming on the first one. So if I keep pressing N, it will be next. Shift N, which is the N capital, it will previous, and so on. Okay. Now what if I want to, for example, if I press enter or N a lot of time. Now actually Vim is not about these only, but these are the most important ones actually, and these you will use them in your daily life. But it has the replacement, it has to run a command, to run something. Okay, it has a lot of features actually. You can read more about it, but for now I give you the most important ones and the ones that you will use in your daily life as a DevOps or developer. Okay, thanks for watching. Now it's time to talk about copying, moving, renaming files. Okay, now actually to create a file we already learned using the touch command to create a text file. So t.text, or let's name it t2.text. Okay, and here you can see that we have t2 and we have t1 or t. Now to copy a file we will use the copy command, which is cp, name of the copy or source, which is this one, and the destination, and we will name it this time t3. Okay, so this will copy the file. So if I cat t3 now, you can see that this is the t3. All right, now this is for copy. Now the same thing for moving, which is using or the cut. Okay, in Windows. Now it will be mv, which is move. So t3.text, it will be t5.text, for example. You can see that we moved the t3 and it from here, and we put it as a t5. By the way, this is the renaming as well in Linux. So in Windows we can right click rename or rename it, okay, or move it to cut it, by the way. But this time move t3 to t5 in the same directory, which means renaming the file. So we rename the file to something else. Okay, now the copy cannot do that, the copy, because it will create a copy from it, so it will not be renamed, the original I mean. Okay, so this is copy and this is move. And to delete a file we already learned that, which is rm-rf or rm-f, and do the file, which is t5, for example, the text. And oh, by the way, we can use the wildcard, so you can see that we have t1, t2, t5. Now if I type it like this, so it will remove everything start with t. But be wary here, be careful, man, because you can see that if you have directories start with t, it will be removed as well, because I'm using rm-rf. Okay, so be careful here. Don't use wildcard randomly like that. Okay, so let's remove that ls without a dash. Actually, yeah, you can see t, all the t's have been deleted. Okay, thanks for watching.
Okay, now input, output, and redirection in Linux. So the first thing, what is the file descriptor? This is something very important in the Linux. Now in Unix and related computer operating systems, a file descriptor, or FD, is an abstract indicator used to access a file or other input-output resource, such as pipe or network socket. So the file descriptor from part of the POSIX application programming interface. So now we have input-output types. Okay, so this is the input-output name, the abbreviation, and the file descriptor for it. Okay, so for the standard input or the input, it is called stdin, and the file descriptor here is 0. Okay, so the file descriptor 0, which means the input. All right, and standard output, which is stdout, it will be 1, and standard error or stderr, it will be 2. Okay, so the redirection here, it will be used for these with these file descriptor. So the, as you can see, greater than here, it will be redirect standard output or redirect standard error to a file. Okay, so overwrite existing. Okay, but with using double greater than, this will redirect the standard output or the standard error to a file, and but this time it will append to any existing content. And here you can see that the less than, this will redirect input from a file to a command. Okay, so this will redirect or take the input for that command from this specific file as standard input. Okay, so again, the greater than or double greater than, this is to redirect the standard output and the standard error. Okay, the same thing for a file, but either to overwrite, which is single greater than, or double greater than, which is to append to any existing. Redirect input from a file, this is used with the standard input to use from a file as input to this specific command. Okay, now let's see an example for the input output. So for example, ls-l, it will show us a long list format for the file, for the files that have here. So we want this output, okay, to be written to a file.txt. So this will put the output of this ls command to this file.txt with overwriting, of course, because we are using a single greater than. By the way, 2 and the output of 2 will be to the div null. Now, if you return back to this table, you can see that the file descriptor 2 here indicates to the standard error. So which means that any error showing here, this is just an example, okay? This can be used with another way. Don't worry, we will have that in detail in the next lecture, the practical one, okay? So this will put any error happens to the null place. So null place here, actually it is like the recycle bin, okay? But with permanently deleting. So sort here, this is using the less than, which is taking the input for this command from this file. So this will take the input from the file.txt for the sort command, and so on. Okay, now in the next lecture, we will have all of that in details with the practice step by step, okay? I will see you there.
All right, now it is time to talk about redirection and the things. Now, I'm assuming that you already watched the theory part about file description, some commands or whatever. Okay, so we will start with the redirection first. So as you can see, if I type ls or ls-l, you can see that I have this specific output, okay? Now, what if I want this output to be inside a text file? So actually, I will type ls-l, which is the command. I will use the greater than here, the redirection, okay? Sorry about this. And then I will provide to a specific file, and I will name it file.txt. Now, if I type ls, you can see that file.txt is here. Let's cat it, file.s. You can see inside it, we have a text of the output of these, as you can see. All right, so far so good. Now, if I want to sort this file, I will use the command called sort file.txt. Okay, so as you can see now, it has been sorted. Okay, now with specific criteria, whatever. Okay, now I'm not talking about the criteria of sorting or the mechanism. I'm talking about the command. And now if I want to provide an input for this, by the way, the greater than here, which means the output of this file, put it inside this file. Okay, so the output of this will be redirected to this file. Okay, this is the greater than. Now the less than, this means that the input for this command, I need it to be taken from this file. So if I type sort, but this time I didn't provide the file.txt, I provide the less than and put file.txt. Okay, this means that for the input of this command, sort command, take the input from file.txt. If I type here, you can see that it gives me the same value or the same result, as you can see. So everything is working as expected. Now, what if I want to put or append value to this file.txt? So for example, I type ls-l for the temp, for example. All right. So I will list all the temp directory content, and I want it not to be overwritten over the file.txt. I want it to be appended on the file.txt like this. Okay, now if I clear the screen first and cat file.txt, you can see that now, yeah, we have, and now this is the part for the first one. This is the second part of the second one, which is the temp directory. All right, so far so good. Now, what if I want to put a specific command? Now, for example, I type ls, let's see here. You can see that we don't have t.txt here, right? So if I type ls t.txt, okay, sorry about this, yeah. As you can see, no such file or directory. Now, what if I don't want for this to be shown? How should I do that? I will do this, which is the lst.txt, and then I will choose this thing, which is to on /div/null. And you can see this time, after I list this file, the same message, no such file or directory, is not written or is not printed. Why? Because the 2, which means the standard error, will be now redirected to div null. And by the way, div null is a device for the null values, which means it's like the recycle bin in Windows, by the way. Okay, somehow, let's say somehow it is that like the recycle bin in Windows. Somehow, let's say. Okay, all right. Now, enough with this. You have an idea now what is redirection, how to use it, and I will see you in the next lecture. All right, now it's time to talk about comparing between files. So if I type ls, I have file.txt and then I have file2.txt. So the file.txt inside it, sorry about this. Inside it, I have this total 1,500, whatever, blah, 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 and total 44 and whatever, okay? Now, for the file 2, actually, it is the same, but it is the first part, which is total 1,000 until we reach total 44, okay? Total 44. So far, so good. Now, actually, for comparing the files, we have three commands. We have diff, which is like this, diff. We have sdiff, which is side by side. And we have the vimdiff, okay? We will handle all of that, okay? Now, let's start with the diff. So, actually, the diff, putting the first file, which is text, and file 2, which is file2.txt. So, you can see that it will start showing that here on this file, which is, as you can see, on the left, which means this file, it has the following, right? And not existed on the file on the right, which is file 2, as you can see. All right, which means that it found that file 1 or file.txt, as you can see, if I open Vim, you can see that file 1 has the following that file 2 doesn't have it. Yeah, and we already saw that. So if I open file 2, actually, you can see that file 2 only has these ones, okay, which is the first part. All right. Now, actually, let's have a comparison between, or let's not comparison, I mean, let's have, or let's edit this, actually, let's put this as a D here this time. And here you can see that I make it as a D, okay? And now let's run the command again. And actually, what we edit on the file 2. So if I open this and make a comparison, so you can see that this time, not just this part, which is this part. On the left file, which is file, it has the following line, okay? But on the right, as you can see, on the right file, we have the following file, or the following content, which is, as you can see, D and slash here, or dash, I mean, okay? So as actually it's run as expected. All right. Now let's use the sdiff this time. So again, file.txt and file2.txt. So you can see that this time it is side by side, which is something more readable actually. So you can see that on the left we have this, but on the right you can see that we have a pipe symbol here. We can see a vertical pipe, which is D here, but this means that here is a dash, which means that this line between the two files, by the way, the one on the right, which is the file 2, the one on the left, which is file.txt. It is simple, no big deal, okay? And you can see that we have the following. All right. Now let's this time use vimdiff, and again the same thing, file2.txt, and open it. You can see now vimdiff actually it is better and it is more visual. And actually, I prefer vimdiff, by the way, but it's okay. It's up to you what you prefer. So you can see that it highlights the text, which is this line that we edited, which, as you can see, not just this line, it highlights the D letter, which is something what is different between this line and this line on the file 1 and the file 2. Okay. And by the way, we have this line is missing, and all of that is existed on this. On the right, I mean, okay? So which means it is work as expected and something human readable, and it is user friendly, by the way. Okay, thanks for watching. All right, now it's time to copy files or move files over the network. Okay, so for example, I have this file here. So let's create it. File over network, for example. Anything, it doesn't matter. Okay, now let's echo or put this inside it. Whoa. File, anything, using the redirection, file over the network, and let's cat it to check if it is, yeah, it accepted it, yeah. So this file over network.txt has a file, and I want to send it to a specific server that I have access on. I have SSH key connected, whatever. Okay, so for that I will use the scp command. All right. So by the way, I have this file here, or I have this server. I have access on it. So over the SSH, I mean. So scp actually, which means secure copy. Okay, and this command used, or you under the hood, it used SSH RSA keys. Okay, so the first thing, scp actually it works exactly like the copy command. So source to destination. Okay, so the source it will be just follow me for now. The source it will be file over the network. By the way, it works from source to destination, which means that you can copy files from here, by the way. So you can copy, for example, remoting.jar from here, from this server, remote server, to your local machine by providing the path here and providing the destination as your computer or as your location on your computer. But how to do that? Don't worry. Follow me for now. So scp file over network.txt. This is the source, which is the file that I have locally. Then the destination, it will be the remote user, which is in my case Ubuntu. As you can see, I am providing the user on that remote machine and I will provide the IP address of it. By the way, I have it as a private server. Yeah, you can see that this is the user. I have access on, which is Ubuntu, which is the IP address of that server. Then I will put the colon here. Okay, the colon here means that this is the server. Now inside this server, what is the path? Which is /home/Ubuntu. How did I know that? It's no big deal. Just type bound here. You can see that home Ubuntu. So I want this file, which is the file over the network, to be copied there. So Ubuntu at this home Ubuntu / so which means that this file will be copied there. All right. So far so good. By the way, don't forget the /. If you didn't specify the /, this file will be renamed Ubuntu and it will be on the home directory. So the / here is very crucial. So / means that it is inside the home, inside the Ubuntu directory. Then we will have this file the same name as here. But if I provide new name _name.txt, this time it will be copied there as this name, which is the new name.txt. Okay, so let's have that. By the way, this is the same thing for the copy. If you want to change the name, we already saw that, by the way, but we didn't mention the / thing, because the / thing is very important and very crucial. So if I type the name of the file, it will be copied and renamed with the new name. But if I didn't provide the name, which means only this, like this will be copied as is, and the default name will be the original name, which is file over the network. But let's put new name.txt. Okay. All right. Now let's press enter. By the way, it will not work like this. You know why? Because we forgot to provide something. By the way, because I am using a key-based authentication here, not a password-based, which means it will not ask me for a password. I need to provide the -i option, which is the identifier, for example. And here I need to provide the SSH key or the private SSH key, so I can send the file. Or, well, actually, I'm assuming that you are familiar with the SSH, the RSA behavior. Anyway, so I have it here actually. Now you can see that it has been moved or copied, I mean, over the network completely with or under a secure tunnel, which is the SSH tunnel. By the way, I'm using again this key. This is the PEM key, or the secret private SSH key. So if I return here, if I press ls, I can see it here, which is the new name. Now if I type new name.txt, a file, which is, yeah, it moved correctly. So actually, let's copy this file, and this time let's name it whatever file, which is on server _file.txt. So this is to distinguish between them. And this file, this time, let's open it by Vim and edit its content. Let's put it something else. What I'm trying to do actually is I want to copy from the server to the local host. Okay, I just want to show you how to do such a thing. By the way, if I press DD, it will delete a complete line. So this is in the server file. Okay, so let's save that and let's see. Now this time I will use the same command, but this time I want to what? Yeah, you guessed right. I want to flip them out. So Ubuntu at this whatever blah 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 and this thing. By the way, you need to change the name, and this will be considered the source, which means that the source I want it from this, which means Ubuntu at something by providing, by the way, the dash I. Don't forget providing the dash I. We already saw that. We don't need to go over it again. So Ubuntu at whatever the IP, this and its place is on this server. I mean, on this server with this credential, this user. Ubuntu home, Ubuntu, not a new name. This time it will be what? Which is the new name we have it here, which is, let's copy it, no big deal. Like this, and the destination, it will be my local machine, which is here. I can provide just /, which means that put this file on the current directory, which is the test. Now let's do that to see if it is working. Yeah, it worked 100%, and yeah, we have it here, which is cat on server. You can see that this is in the server file. Everything worked 100%. But again, I'm assuming that you are familiar with the SSH keys, SSH key pairs, RSA keys, how to modify that, how to configure that. Okay, thanks for watching. All right, now it's time to talk about something very important, which is the alias. Well, actually, the alias, it is something. So if I type ls or man alias, you can see it doesn't have any entry. But if I type alias -- help, you can see that it is to define or display aliases. Alias, it is used to create another alias name for a command. And this is something we already mentioned when we typed the ls-l is the same as ll. You can see that ls-l, which is the same -ll, ls-la, I mean, sorry, ls-la. So let's clear the screen first, and I want to show you just, yeah, ls-la, which is the same like ll. Okay, this will print everything and in a long format. Okay, with some differences. You can see, you can notice that here is a slashes, but here we don't have slashes. Anyway, no big deal. So how to create alias? So for example, I want to clear the screen. I don't need to type clear each time clear. This doesn't make sense. How to do that? Actually, I will use alias command, which is alias, like this, as simple as that. The name of the alias, which is C in my case, equal, and then provide the command, but with a single quotation inside it. So clear. So the command clear will be considered or aliased to C letter. So if I type enter and if I type C, it will work. Oh, so if I type ls-la, whatever ll, okay, I want to clear the screen, I will use just C. Oh, so fantastic. Now, but the thing is, if I open another shell, so for example, I am inside this shell, as you can see. If I open another shell, for example, bash, if I type C this time, you can see C command not found because we didn't put it as an alias. So how to do such a thing without losing the because after we open a new shell session, everything will be removed and specific things will be exported from specific files. Don't worry, we will talk about them right away. Okay, so how to do such a thing? Well, Control D or exit to quit from the first shell. By the way, if I type echo /lvl, you can see that this is the shell level. This is an environment variable and used to print the shell levels. So 1, as you can see, it is to 0. If I open another shell, so if I echo the shell level again, you can see that it is 2 this time. So which means that we have 2 shell levels, which means I am opening a bash shell inside the bash shell. Okay, all right, let's Control D or quit or exit, I mean. Let's clear the screen first. So if I type C here this time, it will work because this is the original one. So how to do such a thing? Now actually, if you notice ls-la, we have something called .profile or .bash rc. And by the way, the difference between .profile and .bash rc, this is used for the specific user, which is Ubuntu. As you can see, any user on Linux, it has the following, either .profile or .bash rc or the two of them. Okay, this is actually used to tell what are the commands or stuff we will do when we open the shell on a specific behavior. So for the dot profile, this is used for the lognable or the login shell. But the bash rc, this is used for the interactive behaviors. Actually, if I vim dot profile here, you can see that we have a lot of information. So you can see dot profile executed by the command interpreter for login shells, as you can see login shells, and the file is not read by bash here. And you can see if the .bash profile or .bash login exist, the file are located in the bash rc package, and you can see the default umask set whatever blah blah blah, and you can see the default file, which is the etc profile. This is not just for the current user, which is Ubuntu. No, this is for the whole system. By the way, I'm just giving you a brief about it. You can read more about it actually. So .bash rc on the other hand, no. So rc like this, you can see that if I have a look here, now you can see that bash rc is executed by bash for non-login shells, okay? There for login shells, which means through SSH, but here for non-login shells, which means interactive. Now let's edit the bash rc. Actually, in my case, what we saw, which is using the bash, we want the alias to be existed. We don't need it to be removed. So from here, just inside this file. By the way, when we open a shell or when we type the bash command, it will everything here will be executed. So which means that I need to provide the alias here. So alias, as simple as that, equal single quotation and then put clear. So this means that every time we open the bash command or put the bash command enter, which means open a new bash shell, and by the way, we already saw it is non-login shells. This is considered to be non-login shells. So this time, which means C will be there. So if I save it for now, and let's open bash this time. By the way, you saw before I go, C, press enter. It's not found. So if I put bash and press C, you can see C is working correctly 100%. All right. And again, so let's exit from that. Let's vim the .bash rc again. Let's copy that actually, and I just want to copy it, and I just want to show you for the login shells this time. This was the behavior for the non-login shells, which means opening the bash using the terminal like this. But for the non-login shells, for the login shells, it will be like this. So .profile, again, put the command here. Be careful, don't put it inside if or else, or if you are using some filtering or whatever, put it inside, in that case, inside if or whatever. Okay, now alias C equal clear. So let's save it. All right. Now I want to quit from that actually, and from that. So you can see that currently I am on my Mus'ab machine, which is the Mac operating system. Now, if I have, actually, by the way, I have this alias. If I type it like this, alias mapper, you can see that I have it like this. This is Ubuntu at something, and this is the key I am using. All right. So let's use this alias, whatever. By the way, this alias is the same as this, okay, as this command, which is as such into the system. No big deal. Okay, please don't get confused. Okay, I'm just using this alias on my local Mac operating system. Okay, currently I am inside this server with this IP address. Okay, let's clear the screen, or I don't need to clear the screen using the clear command. I need it using the C letter to see if it is working or not. Yeah, everything is working as expected. So if I open the bash.rc or .bash rc, you can see that the alias is not here. Let's quit, and now if I open the .profile, you can see the alias, yeah, it is here, which means that this is for the login shells. Okay, so hope you learned. Actually, hope you didn't get confused. Please, if you have any question or if you got confused, you can ask me. No problem. Thanks for watching. All right, now let's talk about the environment variable. Now the environment variable, they are just a variable, but for the system. So you store the directory or the path for the Java interpreter, the compiler, GCC compiler, Python interpreter, whatever. Okay. So the difference between variable and the environment variable is that the environment variable, they are for the system, not just a symbol or a normal variables. Okay, so to show all the variables, we will use the command env or environment. So env, here you can see it will show us everything we have. So the shell level, the look name, path, as you can see, the sh, mail, term, whatever. Okay, now here are some of the tips I want to mention is that the behavior of the shell you are using. So depends on that, you need to know where to define your environment variables. So for example, if you are using SSH, you need to define your environment variable in the loginable shell path. So like the profile. So either the dot profile, the base, the place dot profile, so cat dot profile in the directory of the user, the home directory of the user, which is Ubuntu, like this. As you can see here, you need, as you can see, if you read, you can see executed by command interpreter for login shells. So these are loginable shells or the login shells. Okay, so that's for a specific user. So you created user, called it test, and you created this file. So all the environment variable you defined here, by the way, defining environment variable is no big deal. I will show you right away, don't worry. Okay, so if you defined a environment variable here in the test.profile file, only this test user will have this environment variable, not the whole system. But for the whole system, you will use the path etc profile. Okay, so using any text editor, vim etc profile, and here this is the profile file for the login shells for the whole system. Yeah, as you can see, it is a system-wide. Okay, dot profile file for the burn shell. Okay, so actually this is for the bash, not for all shells. So if you are using Z shell, it will be something else. etc profile.d, whatever. Okay, or etc zsh profile. Okay, so it depends on the shell you are using or the default shell you are using. So if it is a bash shell, now this is the case you need etc profile. Okay, now sometimes it is etc environment, so slash like this, etc environment like this, and here you put the environment variables like you want. As you can see, this is some examples. The name of the environment variable, and it is capital, equal, and in double quotation put the value you want. So it is a key value pair, no big deal. Okay, and after you add the thing you want, either you can quit from the shell and open it again, or using this command, which is the source command, etc environment or etc profile or dot profile file, the path to the file you have entered or typed your environment variable. So source this like this, and it will be here. So for example, let's put anything just arbitrary in the environment. For example, x1. Yeah, by the way, I forgot to open it as a sudo because it is read only. So sudo like this, like we learned. And here, don't worry about the vim, we will talk about it. So x1 equal test, for example. Okay, so let's quit from here, and if I type source, the etc environment, and if I type env, it is not found. Maybe I need to run the sudo command. Okay, sometimes this happens because they are using the POSIX or something like that. Anyway, we can use the dot command. Okay, and by the way, dot not found. Okay, so we can use the sudo dash and then quit from it. And if I type env this time, again, you can see that x1 is found now. Okay, so x1 equal test. And why this happened? Because we quit from the shell and we open it again. Okay, so no big deal, which is the bash shell, I mean. All right, now again, maybe why this didn't work using the source command, actually because this is something for the whole system and you are using the Ubuntu user, which is something not very powerful as the root. So if you type it on your dot profile, depends on the user you want, you will find it there and it will work 100%. All right, thanks for watching.
Okay, processes and job control in Linux. So we will use in this lecture the most important commands here, which is ps-e. This is to display all the processes, or ps alone, actually, it will show the current processes. ps-ef, this display all processes with full information available. ps-u with the name of the user. This is to display the user's processes. For example, ps-u John, ps-u Ubuntu, etc., etc. Top, this is interactive process viewer. This is the same as task manager in Windows, the top, or htop actually. HTOP is interactive process as viewer, as task manager in Windows, but with more features and more graphical user interface friendly. Now we will use the command ampersand or and. So this is to start the command in the background. We have Control C. This is to kill the foreground process. We have Control D. This is to exit foreground process. We have Control Z, suspend the foreground process. And the difference between background and foreground, it is from its name. Background, this is a command or process running in the background, which means not in the shell. We are not seeing the output on the shell or the terminal. But the foreground, which means that when I type specific command and the output will be a real-time outputting to the terminal. Okay, this is the foreground and the background. Okay, we have the BG, which with percent the number. This is to give or to let that process and to suspend it to be a background. FG the number, this the number of the process, by the way. This is to foreground suspend the process. And we have kill PID name. This is to kill process by PID or name. Okay, so kill the name of the process or the PID of the process. Kill -L to display list of signals. Okay, and don't worry, we will handle all of that again in the practical lecture. So jobs and the number of it, or jobs again alone, it will list the jobs. And this number actually, it will be used with the BG and FG. Okay, to let this process to go background or foreground. Okay, now in the next lecture we will handle all of these in details as a practical step by step, so don't worry, stay still.
Alright, now it's time to talk about the processes and the jobs, either background or foreground jobs. Okay, now to see all the processes, actually we are using the first thing, the BS command. So you can see the BS command, it will show me some commands that are running, the PID, the TTI that are used. By the way, this is the teletyper, the PTS. You can read more about it. Actually, I recommend you to read about it. But actually, this is something theory. It will not make a difference for you, to be honest. But it is good to have what is TTY or how a small brief history about the TTY, PTS, something like that. Okay. This is the time, the CMD that is used. Now we have other options, which is -E, which is everything. So if I press it like that, you can see it will start showing every command I have on the whole system. Okay, the PID, this is the TTY that are being used, the time, the CMD as well. Now if you want to see a full information, which is -EF, which means full information, the user, the PID, let's have a look here. Yeah, the PPID, which is the parent PID. So here is C time, the TTY, time, CMD. Okay, whatever. Okay, now if I want to see information about a specific user, so what are the processes for a specific user? So you can see that here for this, which is the www data. Here the Ubuntu, here is the root, here is the mapper, whatever. Now what if I want to see everything for Ubuntu? So I can just provide the -U option. By the way, it's very simple. Ubuntu, which is the name of the user, and press enter. Okay, so you can see that Ubuntu user has only the following processes. Okay, and if I see for root, for example, it will show me as well. Everything here is for root. If I type -U and if I type -F here, you can see it will show for root only and for as a full information. Okay, the PID, PPID, TTY, name, the last, the command, whatever. Okay, all right. Now in Windows we have something called Task Manager to see the task, kill, remove, or actually it has a lot of features, monitor, whatever. Now in this in Linux we have something called top or HTOP. Top actually it show you, as you can see here, is the task, the number of processes, the memory, whatever. And actually I don't prefer top that much. I prefer HTOP actually, because on the other hand HTOP is more elegant. So you can see HTOP is more elegant, give you information about the memory, resources, average, load average. You can see that load average, and the tasks, and how much RAM I have on this server, full, the CPU utilization, and so on. And by the way, the command, the user, the PID, everything is here actually, as you can see, which is something very powerful. All right, so far so good. Now enough with the processes. Let's talk about how to run a specific command in the background. So actually, I have this command, for example, tail-f, and if I run it, it will still bending on the prompt. Okay, so I cannot put anything here. So you can see that. As you can see, I cannot put any command now from now on. So how? Now this is just an example, by the way. We don't use tail-f in that way, by the way. But for example, you have a specific bash script that running and bending on the standard output, like this. So in that case, it's better to run it in the background, which is like this. So tail, which is our example, -f, and shift 7, which means the ampersand, like that. This means that this command will be running in the background. Press enter. Yeah, cool. Now we have it here. So by the way, you can see that we have two numbers, which is this one in the squared brackets and this one. By the way, this one is the PID for this thing. So if I type bs-e and let's use the grep with the pipeline, it's a good practice to see that actually. So 15296. And let's see, yeah, it is here. This it is. And you can see that it is the tail, which is the tail command. Okay, cool. Now what if I want to stop this command actually, or to want to kill it? I don't need it anymore. How to do such a thing? Well, actually we have two ways, either using the kill command, or we can use the BG or the FG, then Control C to interrupt. So Control C, as you can see, to interrupt, Control D to exit, but don't exit, it will exit from the shell. Don't worry, be careful. And Control Z, it will be stop specific process or suspend it, by the way. All right. Now let's start with the kill. So kill, and then provide dash, then provide the number of the signal. And how to know the number of the signal? For now, press kill -L, and here you can see that we have all the signals we have: sig hub, sig serm, count, interrupt, kill, term, whatever. Okay. Actually, the most important ones is the one, which is sig hub, which means that wait until the process complete its work, then kill it, which means hang up first. Then we have the sig kill, yeah, whatever it is, yeah, here, which is 9, and we have the sig term, which is 15. Okay, these are the most important one, but these are not just these few. We have a sig trap, we have sig IO, we have a lot of things actually. I recommend you to read more about it if you are interested. But in my case, I will use sig -9 and then provide the PID. And by the way, the PID, I will just copy and paste it like this, or the name of the process, which is tail in my case. But it is better or a good practice to have it as a PID, not as a name. So here, as you can see, now if I put the grep command again, which is this one, you can see that it is now killed. As you can see, previously it was stopped because it is running in the background. It was stopped. I'm here, but here is killed. So if I type the command again, you can see that it is not existed anymore. So it wait for it, then it will kill. It killed it. All right. So far, so good. Okay. Now let's run this command again. Tail-f underscore or the ampersand. Let's check it, which is the bs-e grep, and put the PID. Yeah, you can see it is here and stopped. So this time, if I kill it, -15, and put the PID, and let's have a PS grep, you can see that it is here. It is waiting. So if I wait a little bit, and if I run this command, you can see that it didn't kill it immediately. So here, -9, which means forcefully kill, but the 15 term. So actually this is used sometimes with some software or programs. So you can see, yeah, it is still here. So again, let's kill it using -9, or actually we need it. We want to learn the other things. Now, again, we already saw what is this number, which is the PID. But what is this? This is the number for the job, which means that we have this as a second job or the index. So if I type the command jobs, it will print all the jobs I have. By the way, I have already this one. So this is the second one. As you can see, the number of job, which is 2. and it is stopped until -f, okay, which is the command. Now, if I use the bg and the number of the job, this means that this job will go to the background. So you can see that now if I type jobs, you can see that it is terminated because we already sent the signal, which is sigterm. By the way, you remember when we type where it is, yeah, here, kill -15, we killed it on using the signal sigterm. Now, if I want to go it, so by the way, if I type jobs again, you can see that now it is removed, by the way. Yeah, because we terminated. Okay, now if I go to FG, this time I will not use BG, FG1, you can see that this means that foreground. BG means background, FG and the number of the job, which is this one, it will go foreground. This means that it will be showing here. So if I type Ctrl C, it will interrupt and it will kill this process. But if I type Ctrl Z, by the way, we already saw the Ctrl C, but if I type Ctrl Z, it will suspend it. Suspend it means that if I have the jobs, again, jobs command, you can see it is stopped. So BG1 and then jobs again, you can see that, yeah, it is here, but it is stopped currently. We don't have it. So if I go again inside it, FG and then the one, and if I click Ctrl C, it will be killed. I guess, let's see, yeah, it will be killed. All right, thanks for watching.
Scheduling repeated jobs with cron. So the first thing, what is cron tab? Now it is a program to create, read, update, and delete your cron jobs schedules. So as you can see here from this picture, that we have this pattern, and this is how the schedule being done. So the first star or asterisks here, it will indicate to the minutes from 0 to 59. The second one is the hour. This is for the day of the month, and this is the month, and this is the day of the week, and from 0 to 6, and 0 is Sunday. And then we put the command to be executed, okay, or bash script or a specific running Python command, etc., etc. Okay. Now the most important commands we will use, which is cron tab the file. This is to install a new cron tab from a file. Cron tab -L, this is to list your cron jobs. Cron tab -E, this is to edit your cron jobs. Cron tab -R to remove all your cron jobs. Now in the next lecture, we will talk about these in details as a hands-on practice. Thanks for watching.
Now it's time to talk about something very important, which is the cron jobs, okay? Now for that, we will use the cron tab command. Now the cron jobs, briefly, they are just jobs that run on a specific schedule. So every 1 month, every two months, every 1 day, every 1 hour, once in the week, and so on, okay? Okay, now for that, I will use the cron tab. So we have the cron tab. So if I have the manual for it, so manual like this. So you can see maintain cron tab files for individual users, and you can see. Now we have the cron tab -L, which means that list all the cron jobs for this current user, which is Ubuntu. As you can see, no cron job for Ubuntu. And by the way, if I provide the name of the user, for example, root, it will print for it. Yeah, sorry about this. I forgot to put -U here, I mean. You can see you must be a privilege to use -U. So you can see you can't put or use or show the cron tabs. So if I type sudo here, you can see that for root as well, no cron tab. Okay, cool. So far, so good. Now, cron tab -E this time, -L to list, -U to see and list the cron jobs for this specific user, -E to edit for the current user, which is Ubuntu. If I type -E space -U, this will give you for a specific user. Now here you can see that we have select the editor you want. Just select whatever you want. Actually, I will use Vim, basic, whatever. And you can see that this is the format for this file. And again, I'm assuming that you already read the theory part because everything is there. So I will not handle the format over and over. And by the way, there is this website, which is the cron tab guru. Actually, I prefer it. So here you can see that it has a lot of things, a lot of values. So how to put your cron tab values. And by the way, there is examples there, which is something very cool. So you can see every 1 minute, every 30 minutes, every Friday, every day at 8 a.m. for example. You can see that here it is. So for now, I will use every minute. Okay, every minute, which means star, everything. Okay, so this means that every minute. All right. So here I will use this thing and then provide the command. Sometimes if you don't need that, you can just provide the schedule, then provide the user, then provide the command. Okay, so it will work, by the way, if you are writing a cron jobs or a cron files. Okay, you can just provide the user you want to be executed. Okay, but I don't need. I will use ls here and I will save. Okay, so you can see that cron tab installing a new cron tab. So if I type cron tab -l, you can see that, yeah, we have it. By the way, it print everything inside the file, and I have the every minute ls. Okay, well, actually this is just arbitrary example. All right, now actually the output of this can be using the redirection. Yeah, we already learned that. But also by default it go to the, sorry, let's have a tail actually, -f. It goes to the var log syslog here. Okay, so you can see that cron info, no mta installed or whatever. So if I wait a little bit, it will show that every minute it will run this command. Let's wait a little bit actually. Oh, cool. So you can see that, yeah, it worked correctly. So here, which is on 11:55, this is the ls command, which is, as you can see, the command for this cron. Another minute, the ls command has been executed, and for this cron. Okay, so everything is working as expected. So let's control C from it. So I will interrupt it. We already learned that. Now let's clear the screen, and I want for this cron tab to be deleted. How to delete all the cron tabs I have? Actually, I can use the -e, by the way, to edit the cron tab, and then I can delete this thing or this cron job. Or if you have, for example, 100 and you don't need any one of them, so you can just do cron tab -r, this to remove all of the cron tabs or cron jobs I have. So now after that, cron tab -l to see, yeah, you can see no cron tab for Ubuntu, which means it worked 100%. By the way, you can edit that, and you can delete a lot of lines using the Vim, by the way, because Vim is very powerful. Anyway, thanks for watching. Now it's time to talk about the history. So you can see that I am typing ls-l, whatever, rm. So you want to see the history of the system. Now for that, I will use command called history, as simple as that. So history, like this. So you can see that I can see all the history of the system. You can see that I have 684 history. Okay, command. So clear, man, sudo, cron tab, whatever. Okay, everything is here recorded. Now, how actually, where is this file that has all the this? Actually, this is not on the history. The history is just to read the history file, the actual history file. So the history file actually for each user, if you type ls-la, you can see that we have .history. Where it is? Yeah, here it is. .history, sometimes it is called .history, sometimes it's called .bash history. So you can see that here it is. So if I vim it or tail it, the .bash history, you can see that we have it here. So by the way, I'm using tail, which is the last 10. So if I open it using list, for example, so let's see, yeah, you can see that all of the commands is here. So you can see that all of the commands, but how much it can take this file. Actually, I got you. This is inside the .bash rc file. Okay, sorry about this. I opened the wrong file. Yeah, you can see that if you scroll down, you will see this for setting history length, see the hi or the history size and the history file size in bash. So you can see the hist file or the hist size. This is for the size, how much history I will gonna record, which means 1000 line, for example. And the hist files, as you can see, 2000, which means 2000 byte or 2000 kilobyte. Well, actually, I'm not sure, because some of them for the byte and some of them for the kilobyte. It depends actually. Okay, so sometimes actually it's better to remove the bash history files or delete it regularly. Sometimes, not all the times. If you are as a root user or as a powerful user, so no one can see what you are doing, or no one can use the credential inside that command. So for example, you are doing something and you are putting the environment variable values, the password, the URLs for the database, the credential for the, for example, AWS IAM access D, access ID, or key access secret ID, whatever. So everything here will be on the console, sorry, on the terminal, will be recorded on the bash. So it's better to remove it from the history, or sometimes to disable the history at all. Sometimes, well, it depends on the situation. Thanks for watching. Alright, now it's time to talk about something very important, which is the sudo su command, okay? Or the sudo wars file. Now, what is sudo? So if I type man sudo, like this, you can see that we will get the execute a command as another user. Okay, so here if you have the description, it allows a permitted user to execute a command as the super user or another user. And the most cases is for the super user, which is the root command, by the way, the root user, I mean. And you can see that here is security policies, sudoer, a lot of options for the sudo, and so on. You can read more if you are interested. But I want to show you the most important things. Now, I am the Ubuntu user. And by the way, I am using that on AWS cloud. So by default, the Ubuntu user or the Ubuntu machine, it has the Ubuntu user, and this user is the power user, which means using the sudo, it will not ask you any question. It will not ask you or prompt you for password. So you can just type sudo ls and you can see everything is here as a sudo. All right. Now this is by default, by the way. So that's why it's better to have another user, not the Ubuntu, the default user, because this is a very dangerous user. This is anyone type sudo or anyone has access on Ubuntu can type sudo and it has the privilege of root, which is something very dangerous. Okay, so for now, let's use the su command. The su command, actually, if I type man su, you can see that this is to change user ID or become a super user, which means if I type su and then type root, you can see that I will go to the root user, but it will ask for a password. The password for the Ubuntu user, by the way. And after I type it to see if I am authorized or not. But actually, I don't have password. I will type Control D here or Control C, Control Z. So let's clear the screen. So I will not use su on itself. I will use sudo su, okay, dash, or without dash for now. So sudo su, it will let this user su go to this specific user by default. If I didn't provide any user, it will be root by default, okay? So I want to go to the root user and using the sudo permission. So if I type it like this, you can see that this time I am the root user. And again, by the way, they didn't prompt me any password or something, because this is in AWS for Ubuntu machines or AMIs, they called it. It is the Ubuntu here, it is the power user, okay? So this is the root. Okay, Control D to exit from the shell, which is the root shell. Okay, now let's return to the Ubuntu. Now, if you notice, after I go to the sudo su, the root user, I still in the home directory of Ubuntu. And we still have the environment variable of Ubuntu. Now, I don't need that. I need to go sudo su, I need to go to the root user, and I need to go to the home directory for root, as well as I want to import the environment variable or export the environment variable of root. So I will use the dash. Actually, it means two things. Go to the home directory of this user you are going to, which is in my case root, and export all the environment variable for this user, which is in my case root, because by default, if I didn't provide any user, it will be root. So press enter. So you can see currently I am root. If I type baud /root, which means the home directory of the root, and it worked 100%. So far, so good. All right. Now let's have a look on the sudo file. So if I vim etc sudoers, you can see that we have this file here. You can see that we have sudoers or sudoers.d. So if you want to edit the sudoers file, it's better to have it on the sudoers.d. This is the best practice, by the way. But anyway, we are just viewing only as a read only. We don't need to change anything in the sudoers. So let's have a look here. You can see that, yeah, permission denied. Why is that? Because this file actually is protected by root. Only root can do that. Imagine if anyone in the system, any user in the system can edit that. So we are fucked up, by the way. Sorry about the language. Okay, so if I type sudo shift1, which is the exclamation mark. Now I will use this to run the previous command, which is this one, as a root. And by the way, you can see it is still read only. But because I am the root, I can edit it. It's okay, because I am the king right now. All right. Now you can see that this is the format, the default environment, default mail, whatever, secure path for the default behavior. These are environment variable, by the way, or variables, let's say. So you can see that here is the privilege we want. So for the root user, we have all equal, all, and the all. Now what are all of these alls? Okay, now all, which means the terminal, or the terminal I am opening in on, or the console. If you are interested, you can read more about it. But what is most important, which is all, which means all user. So run this as all user and run this as all user. And here, all, which means all commands. So root user can run everything as everyone and for every command. Okay. And this is the same thing for the admin groups. But by the way, you can see that there is a percent symbol here. Okay, shift 5. So this means that the admin group, any member inside it, will be able to run all, the same thing. Now this is the same thing for the sudo, by the way. So you can see that here is a percent. So this is a sudo group. By the way, we already saw that. Let's quit from this for now. If I type ID or groups, whatever, you can see that the groups that Ubuntu inside it, one of them is sudo. We already saw that. So let's again open the sudoers file. So you can see that for the sudo group, it is all, and all. But you can see that we have this argument, which is no password. Anyone inside the sudo group will be able to run all the commands as all user or as all group from all terminals or TTYs or BTS, whatever, without prompting any password. Okay. All right. And actually, it's better to edit this file not using vim. Actually, we have the sudo command. Okay, so sudo, and actually it requires you to, as you can see, yeah, permission denied. It requires you to be a sudo, and we already mentioned that. We don't need to talk about it anymore. Why it needs the permission. Okay, so here you can see that we are using, by the way, nano. I don't know why, because this is what they prefer anyway, but it's not bad. I'm not saying it's bad. It's up to you what you prefer. Okay, so here you can see that I can edit anything I want. But by the way, if you can notice here, the name of the file is sudoers.temp, which means that this is to safely secure your file. So by the way, if you, for example, so you can see, yeah, etc sudoers.temp unchanged, so no change has been made. So by the way, if you open the sudoers and if you fucked up here, actually you put some mistake or something, actually the whole system will be down, or the whole system cannot use sudo anymore. So for example, if you don't have an explicit access to the root user, then you are done, actually. Unless you have the physical access on the server, then you will go inside it as a single mode, which means as a root mode, then edit the file, which is the root file, etc sudoers file, I mean, then return it to its original, or modify the mistake that you done until everything is returned back, because actually you are using them immediately. But if you are using sudo, which is this command here, even if I type like this, so imagine with me. So yeah, for example, let's put any arbitrary value. By the way, this is mistake. Yeah, so let's save that. And actually this is bad. You can see that I'm just putting anything, but I'm using the sudo. So sudo, it will not fuck you up. So you will see why. Press enter. You can see that, yeah, it show me etc sudoers syntax error near line 21. Okay, so what now? So press enter, for example. So you can see that the options are either edit sudoers file again, or exit without saving change to sudoer, or quit and save changes to sudoer file. And this is danger. Now, actually, this is not just danger, this is stupid. So if you do that, quit and save the change, even though you got a warning that there is a syntax error for on the sudo file, then maybe you are stupid, sorry for that, or it is for mistake. And if it is mistake, you are forgiven, it's okay, no problem. But actually, I want to E, which means edit sudoers file again, or exit without saving. So E, so you can see here, I can, oh yeah, which is this line, and I want to delete it, just delete everything. Yeah, let's click that, and yes. Let's save this and see, oh, we didn't get any problem. So you can see that no errors shown here, all right? So everything is work fine, which means there is no mistake. But if I edit, so you can see if I edit the etc sudoers file immediately like this, if I put the mistake here, you can see that, yeah, you can see that it is read only, but because I am the root, I can edit it immediately. So you can see if I save that, the whole system cannot use sudo anymore. Why is that? Because there is a syntax error actually in the sudo file. So anyone try to use sudo with something, it will not be working at all. So unless the solution for that, unless you have physical access to the server, which means to open it as a single mode. So if you are using the cloud, you are done actually, no return back. Well, actually, it's not like that. You can just deattach the volume, reattach it again, or change the files there and then reattach it. There is a work for that, a work around it. There is a solution for that, but it is headache and a lot of work to do. And you already have enough work to do actually. And the other solution, if you have an explicit access to the root user, in that case, you can just as such to the system as a root user and then change whatever, because you are the root user, which means you can do whatever in the system and then change the necessary. By the way, the root user, yeah, it is the king on the system and can do whatever it want, but by the way, I can change its privilege. So I can make it less powerful, by the way. And we will not handle that. You can read about it. We will not handle that in this lecture. All right. Thanks for watching. All right. Now it's time to talk about user and groups management. So actually for that, we will use this command. So we have the add user command and we have the user add command. But by the way, I prefer add user. Now, why is that? Actually, they are the same, but under the hood, add user command use the under user command, because the under user command is something within the system, by the way. You can read more about them, what is the difference, but for now, let's use add user, because it is much faster and easier. Because add user, I will add the test user, for example. So you can see only the root can do that. So let's sudo shift1 like that. And yeah, what is the password? 123123. Anything 123123, by the way. Full name, number, other, as this correct? Yes. Or press enter, because you can see that the Y is capital, which means this is the default behavior. So yeah. So now I have the user test. Now using user mode, it is the same, by the way, but you will not provide the home directory. As you can see, add user create a home directory for you. And actually add user, by the way, you can add this user to another group using the same command. Just typing the same command, which is sudo add user, and name of the group, which is, in my case, I will put it inside the sudo group. So it can enable or it can execute root commands as a root privilege. But for now, I will not put it until I show you this something. So I will use the sudo su test, okay? And we already saw that, by the way. So here we go inside the sudo test. Again, let's use the dash option, by the way, or the dash here. So you can see that, yeah, we are inside the test user this time. As you can see, this time it is test here. So if I type sudo ls, it will ask me for password for sure. But if I press enter, you can see test is not in the sudoers file. This incident will be reported, okay? So how to do such a thing? Because the test user is not inside the sudoers or the sudo group, by the way. So if I type id, you can see the groups is only test. Or if I type the groups command, which is test only. So I will control D or exit to log out or exit from the shell for the test user. And then if you cat the etc group, this is where all of the groups in the system, you can see that we have the root and the GID, which is the group identifier, is 0, which means anything with this 0, which means it has the root privilege. So if you can edit the group, by the way, it is readable only for everyone, but no one can modify it, only the root. So if you modify the GID for you, if I scroll down, so for example this, the test, it has this ID or GID. Okay, this is for the group. So if I modify this, it will, as a 0, it will give me as a root privilege. But this is not the best practice to do that. So if I create something else or file, another file, which is something called the etc password, and here inside it, you can see that, yeah, we have it here. So you can see that it has a lot of information, the name of the user, X. Now, what is this X? Which means that we have the password for this user inside another file called etc shadow. We will see right away. Don't worry. This is the UID, the user identifier. This is the GID, the group identifier. And by the way, we already saw that in the etc groups. And here are some of the information values you can put. And here is the home directory for the test user. And here is the bash or the default bash for it, which is bin bash. Okay, so sometimes we can put bin false or bin or user as bin no login, as you can see. Sometimes if we don't need to be for that user to have a shell, like for example the sys here or the bin here, you can see no login shells. All right. Now finally, let's have another look on or a look on the shadow file. But you can see permission denied because this shadow file, it has the hashed password for all of the users. So X means that the password for the test user is hashed and stored inside the etc shadow. So if I open it, yeah, you can see that the test user, which is this one, it has this password or this hash password. Okay, and you can see that it has a lot of information, a lot of values, whatever. Okay, so actually this is the hash for 123123. You already saw the password. This is something very simple. By the way, if I go again to the etc password file here like this, you can see if I edit this one or this one to 0, okay, or the two of them to 0, which means that this is the root user. Let's scroll up a little bit. Yeah, here it is. So you can see that this is the root user and it has a password and it is hashed there. And 00, which means this user ID and GID is 0. This is the root user. So the root user is not just a root user. Why it is a very powerful and root? Actually, not because it is called root, by the way, because it has the 0 UID and GID. All right. Good to know that. Now, I want for the test user to be added to another thing. Okay. So if you click or cat etc groups, by the way, okay, you can see that for the Ubuntu user, here it is. For the test user, oh, sorry, the group. But if I scroll up a little bit, you can see that we will have the sudo. Where it is? Yeah, here it is. You can see that this is the sudo group. And it has inside it the Ubuntu user and mapper user. Now, we want to add, actually, the test user inside the sudo user. The sudo group, I mean. Test user inside the sudo group to perform a sudo commands using the sudoers file that we already learned. So add user, as simple as that. You can see that because using the add user is very simple and it will get rid of a lot of burden actually. So add user, the name of the user that already existed. Now put it to sudo. As simple as, of course, it will ask for a root permission. So you can see that, yeah, adding user to group sudo, adding user to test to group sudo, done. So if I go sudo su dash for test, you can see that this time it give me this information. But anyway, let's put the ID. Now we have the groups, the test, and the sudo. And if I type groups here as well, it has the test sudo. If I cat the etc group again, you can see inside it, if I scroll up, you can see for the sudo group, we have the Ubuntu, mapper, and test. All right. And by the way, the test user is the same as here. Okay. Because by default in Linux, every user you create, it will come with a group. A group will be created automatically with the same name. So Ubuntu, yeah, it has user and group. I have this user mapper, it has this group mapper as well. Okay. Now, by the way, using the user add, actually, yeah, I'm not saying it's bad or something. Actually, by the way, under the hood, add user is using combination of commands, which is a user add and something called user mode. Okay, so after you user add, you create user mode. You put options to create directories or home directory or something. Okay, okay. So that's why I recommend you to use add user. Actually, it is much simpler and it's not powerful. They are the same. No security reason, no performance, and whatever. Okay, they are the same. But add user is very simple. Just add user, the name of the user, and then add user the group you want to add it to whatever group you want. By the way, if I type add user, and for example, let's add test1 is not existed, and put sudo, this will not work. Even if I type sudo privilege, I mean. Now, why is that? Now here you can see sudo add user test1 sudo does, as you can see, the test1 does not exist. So I need to add it first like this and put whatever options I want or whatever password. And here then I can add it here. By the way, if I add it again, it will not work. You can see that the user is already existed. But if I add with sudo, with the group I mean, yeah, it will work fine. And if I add it again, by the way, it will not work because the test1 is already member of the sudo. Now, add user here, actually, it works like that. Actually, it's not like workaround or something. Now, the command itself provides such a thing, okay? Which is creating users and adding users to groups, okay? All right. So far, so good. And if you want, or if you are curious how to use the user add, you can read more about it. Actually, it's not hard, by the way. You can use the two commands, user add and with the user mode as well, to add a user to a specific groups. But anyway, I'm not using it. I'm using the add user. Now, how to delete a user? It is the same, so simple. So if I type man for the del user, this is the command we will use. So you can see this is to delete. We have delete user, delete group. This is to remove a user or group. Okay. So if I type del user, and I type the provide the name of it, which is test. And yeah, of course, I forget that. Then you can see that the test user is now removed. Okay. And again, let's remove the test1, by the way. It is the same. Now, if I cat etc group to see if it is there or not, you can see that it is not here. If I cat etc password to see if the user is there, no, it is not there. Okay. So if I cat with sudo permission the etc shadow, just in case, you can see that as well it is not there. All right, so let's clear the screen and I want to show you something. So if I go to the home directory, actually you can see that even though the user is removed and its group is removed, and it is removed, by the way, if I scroll up here, so if you, yeah, let's cat the etc group again. So as you can see, cat etc group, and if you scroll up to until you reach the sudo, so you can see that it is removed from the sudo group as well. So it has been deleted immediately or completely from the system. But why it is still on the home directory? Now this is something bad, right? You may say this is something bad or wrong. This is wrong. No, actually this is the best practice, by the way. Because for example, you have a specific user and he or she done specific commands in the past, okay? And you want to disable the user, not remove it completely. So that's why the command kept its home directory. So which means every file, each commands he put in the history or each thing will be there. So we can access it. So imagine if I am a root user, okay, so I will not put that. Currently I am a root user and I can go inside whatever I want. So here you can see that, yeah, I am opening everything inside it, the bash history, the bash logout, bash rc, profile, anything here, I can find it in the test or test1. By the way, no big deal. Actually, the del user option here, you can see that we have option which is delete the home directory. So man del user again, you can see that we have it here. Let's search about it. I will give you. As you can see, we have this option which is remove home, as you can see.
So this is to remove the home directory of a user if it's a mail spool or backup specified as dealt after having performed a backup. So dash dash remove home, it will remove the home directory for the current user. Let's have a test, a really quick test, don't worry. So if I type del user test again with sudo permission, you can see that the user test does not exist, all right? So if I type it again, but this time with dash dash remove dash home, okay, which is the option we saw. All right, now if I type ls, you can see that it is still here. Why? Because yeah, we have it. So let's add sudo add user test this time. As you can see, the home directory already existed. So 123 123 123 123 whatever things. Okay. So if I type ls, yeah, it is here and the test is here. So I want to del user with sudo permission, del user test dash dash remove dash home. All right, if I type ls this time, okay, so the test has been deleted, the test user, as well as the test group, as well as the test directory, home directory for the test user. All right, so everything is working as expected, or I can just remove it immediately like this. So if I type sudo rm-rf, the test one, and delete it, you can see that I already delete the test one directory. All right, thanks for watching. Now let's start with the Linux boot process. So in this lecture, we will learn what is BIOS, and we'll discuss about it, the MPR, the grub, the kernel, the init, the run level programs. Okay, now let's start with the BIOS. So the BIOS stands for Basic Input Output System. In simple terms, the BIOS loads and executes the master boot record, which is the MBR, the bootloader. Okay, so when you first turn on your computer, the BIOS first performs some integrity checks of the HDD, the hard disk drive, or SSD, the solid state drive. Okay, so then the BIOS searches for loads and executes the bootloader program, which can be found in the master boot record, which is the MBR. The MBR is sometimes on a USB stick or CD-ROM, such as with a live installation of Linux. Once the bootloader program is detected, it is then loaded into the memory and the BIOS gives control of the system to it. Now for the MBR, MBR stands for Master Boot Record and is responsible for loading and executing the grub bootloader. So the MBR is located actually in the first sector of the bootable disk, which is typically div HDA or div SDA, depending on your hardware. The MBR also contains information about grub or Lilo in very old systems. The grub, sometimes called GNU grub, which is a short for GNU Grand Unified Bootloader, is the typical bootloader for the most modern Linux systems. The grub splash screen is often the first thing you see when you boot your computer. It has simple menu where you can select some options. If you have multiple kernel images installed, you can use your keyboard to select the one you want your system to boot with. By default, the latest kernel image is selected. The splash screen will wait a few seconds for you to select an option. If you don't, it will load the default kernel image. So, in many systems, you can find the grub configuration file at the boot grub.conf or etc grub.conf. So here is an example of the grub.conf file. So it will has these followings, okay, in a single file actually, okay. So you can see that the boot is div SDA, default 0, timeout 5, splash image, etc., hidden menu, title, CentOS, root, kernel, etc. Okay, this is just an example of the grub.conf. Okay, now the kernel. The kernel is often referred to as the core of any operating system, Linux included. It has complete control over everything in your system. In this stage of the boot process, the kernel that was selected by the grub first mounts the root file system that's specified in the grub.conf file. Then it executes the sbin init program, which is always the first program to be executed. You can confirm this with the process ID, which should always be 1. Okay, so check it out, you will see that the init is 1. The kernel then establishes a temporary root file system using initial RAM disk init.rd until the real file system is mounted. The init. So at this point, your system executes run level programs. At one point, it would look for an init file, usually found at etc init tab to decide the Linux run level. So modern Linux systems use systemd to choose a run level instead. So we have run level 0, which is matched by power off the target, and run level 0 target is a symbolic link to the power off the target. We have the run level 1, which is matched to rescue the target. All right. We have run level 3. It is emulated by multi-user target. Run level 5 is emulated by graphical target. Run level 6 is emulated by reboot target. And systemd will then begin executing run level programs. All right. Which is the run level programs. So depending on which system distribution you have installed, you may be to see different services getting started. For example, you might catch starting send email. Okay, these are known as run level programs and are executed from a different directories depending on your run level. Each of the 6 run levels described above has its own directory. So we have run level 0, etc rc0d, run level 1, run level 2, 3, 4, 5, and 6. Okay, and you can find them in the etc rc123.d, etc, etc. Note that the exact location of these directories varies from distribution to distribution. If you look in the different level directories, you will find programs that start with either an S capital A, K capital for startup and kill respectively. Startup programs are executed during system startup and kill programs during shutdowns. Okay, so far so good. Thanks for watching.
Alright, now for the file system. Well, actually, I want you to learn some of the commands. I will not go too deep into it, actually. So we have the df command, the du command, the lsblk, the list block, and we have the mount command, okay, which is like this, okay. So let's start with the first 3, then we will go to the mount. Okay, now here we have the df-h option, okay. So here is, if you can see man the df, you can see to report file system disk usage or disk space usage, okay. So actually this is used to show all the information about the disk you have or the file systems, let's say. So for example, the udiv here, the size, how much it used, how much it is available, and the use in percent, and where it is mounted, okay. So for example, for here we have the div xvda1 and the used is 1 giga, as you can see 1.2 from 8 giga, okay, and the available is 6.6 and it is used only 15%, okay. And you can see where it is mounted. It is mounted in the slash, which means that everything. So if I go there like this, you can see that all of these files or directories are mounted there, or are there existed on the xvda file system, okay, or this volume, let's say. What if I want to see the size of this specific file or directory, okay, or all the files inside this directory? We will use the disk u or the du, the disk utilization. So for example, you can see that we have this init.rd.image, whatever, okay. So du -h, and by the way, if you notice that I type -h here in the df options as well, -h means that the human readable. So as you can see, the size is in megabyte, in gigabyte, instead of typing it as a byte, okay. So because if you saw like this, let's return back here. So if I type df-h, or without -h, I mean, this time you can see that the udiv, yeah, here the udiv is 452 megabyte, but here is a very long number and you don't need to divide by byte or by kilobyte, and this is not readable so much like the df-h, okay. So that's why we use the -h option. So for the du, again, let's return to our example. Let's return to the du, okay. So du disk utilization -h for the init rd image, okay, like this. And if I click on it, you can see that its size is 0. Okay, well, maybe I should choose another one. Let's choose this VM Linux. Don't know if this is 0 as well. Yeah, okay, whatever. Let's go to the here for the file 2 du-h file 2. Okay, like this, and you can see that it is in 4 kilobyte, so its size is 4 kilobyte. All right, so again, without dash h option like this, you can see that it is 4 only, so actually this is not readable. Now what if I want, for example, let's clear the screen, let's cd dot dot. Okay, yeah, by the way, this is something we didn't talk about actually, which is the dot directory and the dot dot directory. By the way, dot directory, which means the current directory I am in. Okay, the dot dot, which means the parent directory, because if you noticed, if you type this command ls-l a means all files. So if you can see here, you can see that we have these two directories, the one, the dot, which means the current directory, and the dot dot. The dot dot means the parent directory of the current directory. So if I type the pwd, the print working directory command, you can see that it is start from the root, the home, Ubuntu. Okay, so currently I am inside the Ubuntu directory. So the dot here means the Ubuntu directory, which is the current directory I am in. The parent directory is the home directory. All right, as you can see, the owner and the group is root, which means the home directory, which is something inside the root, or the root, for the root user. All right, so if I type cd dot dot to go to the parent, and these are called relative path. Actually, there are two paths, absolute path and relative path. The absolute path, you put the path like this, just copy and paste and put the absolute path starting from the root directory, all right, which is slash in my case here. But the relative, which means that from where I am. So dot dot this means that I am using a relative path. Okay, so which means the parent directory, which means I am in Ubuntu, I will go to the home. So if I click here and I type bout again, you can see currently I am in the home. So if I type ls-l a, you can see that we have 3 directories only, the current directory, and in my case here it will be the home directory. As you can see, the owner is root, the group is root as well, but the Ubuntu directory here is for the Ubuntu user. All right, now what if I want to see the size of this directory? I will use the disk utilization command as well on Ubuntu, but you can see that it shows us everything actually. Yeah, please ignore about this. Remember when we put it to not be readable or executable. Anyway, it's okay, no big deal. So you can see that it shows us everything actually. Then it shows us the whole size for the whole directory, which is 64 kilobyte. Now what if I don't need to show all of these options and I want to show only the Ubuntu, the size for the Ubuntu directory? As simple as that. You will put the -s option, which is like this, hs. Now s means summarize, so summarize only the directory I wanted, so which is Ubuntu in my case. So you can see that it shows us like this. All right, now please ignore about this. So actually let's remove it, or we can change the permission for it, but for now let's remove it, and it's good exercise for now. So actually it is a file, which means I don't need to provide the path for it. So if I type it like this, actually I need to remove the directory itself. So if it is a directory, which means that I put -r, and yeah, as you can see, if you can see, it is permission denied. I need to put it rf. If this didn't work, I need to put the sudo dot dot and it will be removed. Okay, so if I type the commands again, which is the du-hs as well, you can see that now it is only summarized for the Ubuntu user, and as you can see, the size is 60 kilobyte now, not 64. As you can see, it has been decreased. All right, now finally the last option or the last command we have, which is the mount. As you can see now, actually let's put man mount to see the manual page for it. So this is actually to mount a file system. So the syntax is like this: mount, then put the options you want, choose the type, file, -a, and all of that is actually here documented well actually. So you can see if only the directory or device is given. For example, you can put mount /dir or -- target, whatever. All right, And actually, this is something used if you want to attach or mount volumes, external volumes, for example, or you inserted external volumes and you want to mount them here after you add them, for example, on the AWS. So, for example, in AWS, there is something called EBS, Elastic Block Storage, and this is something to attach another or extra volumes, not the root volumes, and you want to mount it. Well, actually, I will not go into details into the mount options because they will give you all the options or all the commands, just copy and paste them there. All right. Now, in that case, either AWS, Google Cloud, Azure, whatever. Okay. They will provide you with all the thing you want. So the mount here, just keep in your mind that we will use it for mounting the file system or the volumes we want. Just that's it. Okay. Now remember the format, the syntax, the options. Just read the manual, depends on what you need. Okay, I will not talk about it in details here. All right, thanks for watching. I will see you in the next lecture.
Let's start with shell scripting for beginners. So actually, shell script is a list of commands in a computer program that is run by the UNIX shell, which is command line interpreter. A shell script usually has comments that describe the steps. So in this course, we will handle the most important things about shell scripting, like the variables, the special variables, operators, if else, and case sac, which is the to close the case statement, and loops with functions. Okay, now we will start in the next lectures, start learning all of these in details. Thanks for watching.
All right, now it is time to talk about the operators. So if I open the shell and let's remove these. Okay, so var1 or var, let's put inside it. Now actually I will put the back quotation. As you can see, back quotation means that you will put a shell command inside this variable. So if I type echo hello inside this var and I echo var, it will give us hello. Okay, so echo in double quotation hello. Okay, let's see that. Yeah, and then echo var, this should give us hello. As you can see, it is hello. All right, so again, let's return here, and inside it I will use this command, which is the expr or the expression command. So expr command, sorry, expr. Now put 1 plus 1, for example, and then echo the var, then save it, then let's run the shell. You can see that it is 1 plus 1. Now you may ask me why this happened, because actually we forgot the spaces between 1 and the plus and the 1. Okay, so actually this is very important in the expression. So here it will give us what we want. So if I run it again, it will be 2, which means the expression worked correctly. Of course, you can put minus, multiplication, division, modulus, a lot of things. Okay, thanks for watching. I will see you in the next lecture. All right, now for the decision makings, we have actually 3 types of formats: if phi or if else phi, then we have the if elif phi. Okay, phi here means the end of if statement. Okay, so let's have a look at the syntax actually. So you can see a equal 10, b equal 20, and if a equal b, and as you can see the $sign, echo a is equal to b. If not, as you can see, not equal is equal to b. Now this is for the string. Now if it is an integer number, or if it is number, we will use the dash eq dash less than dash lt, I mean dash le less than or equal, gt greater than, dash ge greater than or equal, and so on. Okay, or dash equal or dash not equal. But anyway, for now, walk with me on this. You can see that if a equal b, then it will show us like this. So it is time to run this. So shell, you can see a is not equal to b, but you will get this unexpected operator. Now actually there are no syntax error here, but the thing is, because I am using and it is executed as sh only. So if I type s bash shell.sh like this, you can see no errors at all. A is not equal to b, and that's it. Okay, Now for the second format, we will use this. As you can see, a equal 10, b equal 20. If a equal b, then echo a is equal to b. Else, as you can see, else echo a is not equal to b. And you can see here, we put the phi, which means that the end of the if statement. As the previous, but this time we added else, all right? So nothing new here, okay? Now finally, we have the if, and else, then phi, okay? So as you can see, a equal 10, b equal 20. So if it is a equal b, then equal a is equal to b. Elif, as you can see, elif and open. It is like the if, but with else plus if, okay? So elif a not greater than, as you can see, dash gt, greater than b. Elif a is less than b, as you can see, so it is less than. Else, so none of the condition met, okay? So let's run this actually and see what will give us. Yeah, a is less than b, but anyway, ignore this because this is sh, not bash shell. So if I bash shell, no problem at all right? Now finally, we have the case statement, and you can see that the fruit is apple, and the case fruit in either this one or this one or this one. But you can see the syntax is like this. So case, then in double quotation I put the variable that we store here, then in, and as you can see, double quotation, and another double quotation, and we have the half of brackets like this. Then if it is right, echo this command, and you can see we have two semicolons, which means the end of this case, okay? So banana, again, double quotation, this is the choice we have, and we close it with this bracket, and echo I like banana, for example, and we have two semicolons, which means the choice has been ended, no more commands. Now finally, we have the mango and echo woo, for example, and we have two semicolons, and which means that the case ended here, okay? So no more commands. And finally, we have the case but with a reverse way, okay? So ESAC, as you can see, case ESAC, all right? Now let's run this and see what will give us. So if I run the shell, apple pie is quite tasty because the choice was, or the fruit was apple, okay? Actually, there are other way to do that. Instead of putting it as hard-coded, you can just put and add the dollar sign like this. And here inside it, if I type shell apple, you can see apple is yummy. Apple pie is quite tasty. And if I put mango, whoa, and again if I put something like this, nothing will appear, okay? All right, thanks for watching. I will see you in the next lecture. All right, now let's talk about the loops in shell scripting. Okay, now this is an example, as you can see, for shell scripting. A equals 0 while a not dash lt 10, which means less than 10, which is this is the loop, the first loop. Then b equal dollar sign a, then while b not greater than or equal 0, as you can see, do done. All right, so as you can see, while after we open it, do, and after I finish, done, okay? So do, done. So if I run this actually, well, you can just copy and paste. Actually, you can write it yourself. It's no big deal, as the syntax is the most important thing here actually. So how I can write a while loop, this is the syntax. Other than that, it's up to you, all right? Or it depends on you what you need to do, all right? So let's quit from here and let's run it. You can see it will show us something like that. And actually, this is something nice. Now this is for the while loop. Now for the for loop, actually, well, actually there are other loops like the until or like the select, but I will show you just the for and while. So this is an example, okay? So I want to delete this first because I forgot to remove it. So var1 in 1, 2, 3. So do and done, okay? So which means this is the body of the for, and this is the second for in 0, 5. Do and done, all right? So you can see. Now if var is equal than 2, and this means and, okay? Var is equal 0, then break 2, else echo var1, var2, okay? So actually we used the break, which means it will break from the inner loop, which is the inner for loop. Okay, so let's run this and see what will happen. So if I run it, it will show us 1 0 and 1 5. Okay, so if I go again, you can see that the first loop go through in 1 2 3. So the first number is 1, and we go inside the var2, or the second loop, I mean, and var2 in 0, so it will start with 0. So which means that now they are not equal. As you can see, var1 is not equal to 2, and var2 is not equal to 0. So which means it else. So we will print the var1 and var2. The same thing for the 2. Well, actually, it doesn't matter about the logic. What is matter for you now is the syntax, actually. So how to use a for loop. And here is the syntax. So for something, or the variable in a list, as you can see, like these 1 2 3, or a b c, or anything, and do done. Okay, so after you done from the for loop, which means this is the end of the loop. Okay, and it will keep looping until these are completed. Okay, so it will go through 1 2 3. All right, depends on the condition we have here. And by the way, we can use, instead of break, continue as well. Well, actually, it is basic programming. Anyway, thanks for watching. All right, now let's start with the variables and special variables in the shell scripting. Okay, now the first thing, let's create this file and let's name it shell.sh, like this, and ls-l to it. You can see that it is not executable. So chmod plus x, or user plus x if you want it to be more secure, whatever. Okay, ls-l to make sure it has taken, yeah, it has take this execution permission. So vim shells sh here, the first thing you need to provide this thing, as you can see, which is the bin bash. All right, so which means that if I interpret, or if I execute this file, it will be interpreted, or it will be interpreted by using this utility, and this utility is the bash shell. Okay, so var equal hello. Okay, as simple as that. Now, and here I will type echo, and with the $sign var. Okay, so when I assign the value without $sign, when I echo the value, or print the value with $sign. All right, so exit shift, yeah, here. So as you can see, dot slash shell. Okay, now please don't get confused with the dot here. Dot, which means it is in the current directory. So if I actually, this will work. So let's see this. Yeah, hello, this is the same, will work if I typed the absolute path like this, and then shell.sh. You can see that it has worked successfully, no problems at all. All right, now here for the variables, you can see that they are very simple. By the way, you can put strings, you can put characters, you can put integers value, floating, whatever. Okay, all of that will be worked. Okay, no problem. But again, so the operation, like the summation, the addition, the subtraction, division, that has a different case, and we will handle it in the operators lectures. Don't worry about it. Now for the special variables. Now actually, I summarize it here in this table. You can see that we have the $0, $n, $, hashtag, $star, $at, and question mark, two $signs, and $sign with the exclamation mark, okay, or shift one. So the first thing, which is the file name of the current script, okay. So if you type this, actually, if you go to it, shell.sh, and typed here echo the $0, like this. Now let's run again. You can see that it will be given the name of the shell, which is the home ubuntu shell.sh, because as you can see, depends on what you executed. So if I type like this, shell.sh, it will be shell.sh. And to get rid of the directories, you can use the command called dir name, whatever. Okay, just you can read about it, depends on your usage, whatever. All right, so the other thing, which is the -n, and this is, as you can see, the numbers actually. So $1, $2, whatever. So this will be the arguments that are used. So for example, if I type sh, the shell, and I typed first, then second, then whatever. Okay, So you can see that this is the first argument and this is the second argument. And if I typed the shell.sh here, for example, and I typed echo1, then echo $2, okay? So let's see, shell, again, let's shell first, second. You can see that this is hello, this is the first one, has first and second, all right? Now, here the number of the argument, which is the hash, the number of the arguments. So actually I type 2. Now if I print it actually, so let's see. So let's delete that, we don't need it. Actually, if I print it actually like this, all right? So let's see what will give us. Yeah, 0, nothing. But if I typed the first, second, it will be 2, okay? Which means 2 argument has been selected. Now we have the star here, which means that all the arguments that are double quoted, and you can see that it is equivalent as 1, 2, 3, 4. So for example, you typed 4 arguments and you want to show them all, you can just type this and it will show all the arguments that you have typed, okay? And the at here, $@ is the same as $* with some differences anyway, but they are the same somehow. Okay, now for the $? And actually this is very important, which is the exit status of the last command. So for example, let's go here and I typed $? Which means 0. 0 means that it has been executed correctly. But if I type this command, this is not a command, actually this is a wrong command. And if I typed echo $? It will show us 127, which means that this is error. The last command, which is this command, has been issued as an error, okay, which means the command not found. Okay, actually this is a not command actually, but anyway, I'm just showing you, all right? And we have the $, which means the process number of the current shell. So this will show us the PID of the shell, as you can see. So if I go here and vim shell.sh and I type $, and run the shell again, let's see, it will show the PID for the shell, okay, that has been executed. And finally, we have the $! Which means that we need the process number of the last background command. So let's go here, shell, and put it like this, and let's echo it, and let's see what will show us. And you can see that nothing at all, because we don't have any background command running, all right? By the way, to running anything in the background, you can issue the command, then put the and or the ampersand, okay? Shift 7, okay? So this will run this command in the background. So for example, if I run it like this, you can see we got this PID and it is running in the background as well. As you can see, this is the number of the job, by the way, okay? By typing Ctrl-Z or Ctrl-C, it will go and exit from the job, all right? Thanks for watching. I will see you in the next lecture. Now we will talk about the shell functions, okay? Now this is a simple example, as you can see, which is the hello function. As you can see, you define your function here. So hello, and open the brackets, open the braces, and echo hello world. Now to invoke your function, you can just call its name, which is hello, like this, and it will print hello world. Now let's see what will happen now. So shell, yeah, hello world, it worked 100%. Well, actually, this is a simple lecture and quick lecture, but we talked about how the function work, okay? And it is exactly the same as the basic of programming, okay? When you invoke the hello function without putting the brackets, just the name. All right, thanks for watching.
Now let's start with the interview preparation. Let's start with part 1. So the first question any interviewer will ask you, what is Linux? So actually, I recommend you, before you start, I want you to see the question, try answer it, and then see the answer yourself, okay? So actually this will give you a better idea and better understanding and better preparation for the interview, okay? So the answer is Linux is UNIX based operating system. Linus Torvalds first introduced it, and actually Linux is a kernel, as we mentioned before. It is a GNU Linux that makes the kernel with the GNU free software. So it is an open source operating system that was designed to provide free and low cost operating system for the computer users. Now, the second question, what is the difference between Unix and Linux? Please try answer it. Yeah, Unix was originally started as proprietary operating system for Bell Laboratories, which later released their commercial version. While Linux is a free, open source, and non-proprietary operating system for the mass uses. Okay, now this is just the full answer. Okay, actually you can just say anything, but be prepared. What is Linux kernel? Linux kernel is low-level system software. It is used to manage the hardware resources for the users. It provides an interface for user-level interaction. Is it legal to edit Linux kernel? Yes, you can edit Linux kernel because it is related under General Public License, GPL, and anyone can edit it. It comes under the category of free and open source software. So yeah, it is legal. What is Lilo or Lilo? So Lilo is a bootloader for Linux. It is used to load the Linux operating system into the main memory to begin its operations. So it is the bootloader for the Linux system. What is the advantage of open source? Open source facilitates you to distribute your software, including source codes, freely to anyone who is interested. So you can add features and even debug correct errors of the source code. Now, what are the basic components of Linux? Just like any operating system, Linux has all components like kernel, shells, GUIs or graphical user interface, system utilities, and applications program. What is the advantage of Linux? Every aspect comes with additional features, and it's provide a free downloading facility for all codes. So this is one of the advantage of Linux. By the way, this is not just the absolute answer. You can answer everything, but this is one of the suggested answers that will make the HR or the interviewer, let's say actually the interviewer, the technical interviewer, more interested about you. So you know your stuff. Define the shell. So it is an interpreter in Linux. So like you put your commands on it and it will start giving us the short output. Name some shells that are commonly used in Linux. The most commonly used shell in Linux are Bash, C shell, K shell, B shell or BSH. Name the Linux that designed by the Sun Microsystems. It is Solaris. Solaris is the Linux of the Sun Microsystems. Name the Linux loader. So yeah, the Linux loader by default, or the most original one is Lilo or Lilo, is the Linux loader. Okay, so we have grub actually, and this is what we want to ask about it, or they may ask about it. What is the difference between Lilo and grub? So the main difference between grub and Lilo or Lilo is that grub can be used for various operating systems, while Lilo or Lilo is used only for the Linux operating system. Okay, I will see you in the next lecture. We will talk about the part 2. Thanks for watching. Okay, now let's start with the interview preparation part 2. Okay, now again, I recommend you to have the question, like for example, this question, read it, then pause the video, try to answer it yourself, and then see and compare your answer. Now again, this is not the ideal answer or the only answer. It has a lot of answers, okay? Okay, now this question. If you have saved a file in Linux, later you wish to rename that file, what command is designed for it? The mv command is used to rename the file, okay? Now, define the inode, or what is inode? Each file is given a unique name by operating system, which is called as the node or the inode. Okay, so the inode here is like, it has all the information of them are about the metadata. Actually, it is data about the metadata, like the access, last modified, the permission, the name, owner, group, all of that actually. Now, if the programmer wishes to execute an instruction at the specified time, which command is used? The at command actually is used for that thing, okay? Explain process ID. The operating system uniquely identifies each process by a unique ID called as the process ID or PID, okay? Now, name some Linux distro variants, okay, or distribution. Yeah, some of them are actually CentOS, Ubuntu, Red Hat, Debian, Fedora, and Kali Linux, etc., etc. What is the swap space? So swap space is used to specify a space which is used by Linux to hold some concurrent running program temporarily. And it is used when RAM doesn't have enough space to hold all the programs that are executing. Now, what is Bash? Bash is short for Born Again Shell. It was a replacement to the original Bourne shell written by Steve Bourne. What is a root account or root user? The root account is like a system administrator account or user. It provides you full control of the system. You can create and maintain user accounts, assign different permissions for each account, etc., etc. What is CLI? CLI stands for Command Line Interface. It is an interface that allows user to type declarative commands to instruct the computer to perform operations. Now, what is the GUI or Graphical User Interface? GUI stands for Graphical User Interface. It uses images and the icons which are clicked by the users to communicate with the system. It is more attractive and user-friendly because of the use of the images and icons, etc. Unlike the CLI, it is using only the interpreter or shell, like a text only. Okay, thanks for watching. Okay, now let's start with interview preparation part 3. Okay, now again, I want to see it again, see the question, pause the video, and try answer it yourself, and compare the answers. Now, is Linux operating system virus-free? No, there is no operating system till date that is a virus-free. So no, Linux is not a virus-free. But Linux is known to have less number of viruses because it is very strong and very good operating system. Now, which partition stores the system configuration files in Linux system? It is *stc partition. Okay. Now again, this question may be asked, okay, at the interview, but it doesn't harm to know it, right? Which command is used to uncompress gzip files? gunzip command is used to uncompress gzip files actually, or you can use the gzip command itself using the -d option. What is the virtual desktop? The virtual desktop is used as an alternative to minimize and maximize different windows on the current desktop. So it facilitates you to open one or more programs on a clean slate rather than minimizing or restoring all the needed programs. What are the file permissions in Linux? There are 3 types of file permission in Linux OS that are given like below. Read, which user can read the file and list the directory. Write, user can write a new files in the directory. Execute, user can execute and run the file in the directory. How to exit from VI editor? What is the shortcut or what is the key used for that? The following commands are used to exit from VI editor. We can use the :WQ to save the current work and exit. We can use quit without saving. This is to force. The exclamation mark here is to force to quit. Also, we can use the :X as well. But this is we'll use write and quit, okay? As we mentioned before. How to create a new file or modify an existing file in VI. So we can just use the command VI and the file name, or vim the file name, okay? So as we mentioned before, the vim is an improved version of the VI. What is redirection? So redirection is the process of directing data from one output to another. It can also be used to direct an output as an input to another process. What is grep command? Grep, a search command that makes use of pattern-based searching. It makes use of options and parameters that are specified along with the command line and applies this pattern in searching the required file output. I think we have reached to the end of the slides. So if you got confused of any of these questions, you can read more about it online or you can ask me directly, no problem at all. Good luck and thanks for watching.